Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Good evening, dear students. Welcome all to the concept builder of 11th physics. We are 2024 examination. We are only having this remaining 4 or 5 days there. So within these 5 days, we can improve our concepts and we can score maximum possible questions from physics. Today we concentrate on the 11th topics, which will give us definitely more than 22 or 23 questions definitely will be there. So what's our plan today is to revise the topics of all chapters of 11th physics quickly, and we are solving some questions for a practice. Okay, so you guys should be there with your pen and copy, and you practice all the questions what we are doing here. And also you note the theories. If any of the theories not well aware of those concepts with you, then you can also note them also. Okay, so let's start the topics. The first chapter is units and measurements. It's a very simple chapter. These are the topics we need to focus. Fundamental, supplementary and derived quantities. These are the physical quantities. Then dimensional analysis, an important topic there, the dimensional analysis. Then error in measurements, error, measurement, combination of errors, etc. And also significant figures, then screw gauge and vernier calipers. Okay, we can deal with all these topics one and one. Okay, the first one is fundamental, supplementary and derived quantities. We know there are 7 fundamental quantities are there. Fundamental quantities are 7: length, mass, time. Okay, we can use this dimensional symbol as, see, length, then mass, then time, then temperature, then electric current, then luminous intensity, then amount of substance. Okay, these are the 7 fundamental quantities we are having. Okay, now their dimensional symbol is accordingly written here. Okay, and what are the supplementary quantities? We know supplementary quantities are solid angle. This is a plane angle. We know this is a plane angle d theta, and there is a solid angle also there, solid angle like this. Okay, this is a solid angle. These are supplementary quantities. Solid angle can be written as dO. Okay, what are the importance of these supplementary quantities? They are having units but no dimension. Units but no dimension. Okay, see, unitless quantity. Unitless quantity is definitely dimensionless. A quantity which is unitless quantity, physical quantity, which is definitely dimensionless. Okay, this is asked in the last year NEET examination. But a dimensionless quantity, you know, a dimensionless quantity does not mean that it is definitely unitless. For example, plane angle has no dimension, but it is having unit. The SI unit of plane angle is radian. We know that is radian. Okay, what is the connection between radian and degree? We studied that pi radian is equal to 180 degree. Okay, pi radian is equal to 180 degree. Okay, for example, pi by 3 radian. What is pi by 3 radian is how much degree? You replace this pi radian as 180 degree. 180 degree divided by 3. Okay, it is 60 degree. It's very simple, direct conversion. Okay, and what is the SI unit of the solid angle is steradian. Okay, questions connecting the steradian is seldom coming. Okay, it's hardly coming, so no need of studying that. Okay, just this conversion of degree into radian or radian into degree is very important. Okay, so these fundamental quantities 7, then supplementary quantities 2, rest of the physical quantities are known as derived quantities. Okay, very good, it is done. Okay, then the next topic here it is dimensional analysis, the uses of dimensional analysis. Okay, the very important point is the principle of homogeneity. What is the principle of homogeneity? Suppose we are having a physical expression as A is equal to B plus C. If this expression is true, which means dimension of A and dimension of B and dimension of C must be same. Okay, the dimension of each term in a physical expression must be same, then only that expression will be true. This is the principle of homogeneity. For example, if this is length, this also should be length, and the summation of this length should be another length. Okay, that's it. Okay, for example, suppose something is added to a number, for example 1 plus v by x, suppose, okay, 1 plus v by x, y is equal to, where v is velocity, then I ask you what is the dimension of y, what is the dimension of x? Find the dimension of y, find the dimension of x. What is your idea? See, this v by x is added to 1. This is a dimensionless number. Then for this to be true, then v by x is dimensionless. V by x dimensionless means x having dimension that of v. Suppose v is velocity, then what is the dimension of x is lt raised to minus 1, that of velocity. Okay, and this 1 and this is added to get to y, means y is another number. It is not having any dimension. So this is dimensionless, y is dimensionless. Clear? I think you understood this. Clear? This is the principle of homogeneity. And you remember that trigonometric identities, trigonometric functions are dimensionless. There is sine theta, cos theta, tan theta, etc. These are dimensionless. Okay, and this argument, that is also dimensionless. Clear? For example, this sine of kx plus omega t, this is very familiar with us. What about this kx? Kx is an angle, it is dimensionless, it should be dimensionless. Omega t, it also should be another angle, and that is also dimensionless. Okay, then what is the dimension of k? Is the inverse dimension of x. If x is in meter, then what is the dimension of k? The dimension of k is L raised to minus 1. Clear? Similarly, what is the dimension of omega? That is the inverse dimension of time. Okay, and also these exponential functions and logarithmic functions, these are also dimensionless. And suppose this e raised to x, then what about this x? X is a number, it is dimensionless. Clear? X is a number, it is dimensionless. For example, e raised to bt is there, suppose e raised to bt, which means this bt is dimensionless. It should not be having any dimension. Means the dimension of b is the inverse of time. So what's the dimension of b here? Here is t raised to minus 1. Clear? That's fine. Now, see, and the uses of dimensional analysis, we can derive the physical expression. One such question is here. If force F, acceleration A and time t are chosen as fundamental physical quantities, find the dimensions of energy. How to solve this? Here in this question they are saying that force, then acceleration, then time are to be taken as fundamental physical quantity. Then what should be the dimension of energy? This question is solved like energy, we write this energy proportional to force raised to A, then acceleration raised to B, then time raised to C. This is the first step. Okay, then this energy is equal to some constant k, this is dimensionless constant, force raised to A, acceleration raised to B, time raised to C. Okay, then what is the dimension of energy should be the dimension of k is dimensionless, dimension of force raised to A, dimension of acceleration raised to B, dimension of time raised to C. Okay, and what is the dimension of energy? We studied that m L square T raised to minus 2. That knowledge we should have. Okay, all of us know that. And what is the dimension of force is m L T raised to minus 2. Okay, m L T raised to minus 2 all raised to a. Then what is the dimension of acceleration? That is L T raised to minus 2 all raised to b, then time t raised to c. Clear? Then here on LHS we are having m raised to 1, then L raised to 2, t raised to minus 2 is equal to, here it is m raised to a only, m raised to a, m raised to a. We understand this a is equal to 1, a is equal to 1. Here the a is the power of f, and quickly you check in the option, f is having the power 1 in all the options. Okay, then moving to the next one, L raised to a, L raised to b, that is L raised to a plus b, L raised to a plus b. Then what is this a plus b then? When we compare this, a plus b is 2. Then where a is 1 means a plus b is 2 means b is also 1. B is also 1, and b is here the power of a. So here acceleration should have power 1. So a is having power 1 here, a is having power 1 here also. Okay, and here also it is correct. Then we need to check the another one is t raised to minus 2a, t raised to minus 2b, t raised to c multiplied, that is t raised to minus 2a minus 2b plus c. Okay, on comparison we understood a is equal to 1, b is equal to 1, we already understood. Then minus 2a minus 2b plus c is equal to, what about that? On LHS this is minus 2, minus 2. Okay, now this is minus 2 plus c is equal to minus 2. Okay. Clear? Then that is this c is equal to minus 1 plus 4. Okay. C minus 2. Okay. Minus 2 plus 4, it is 2. Okay. C value is 2. C value is 2 is what? C value, A value 1, then B value 1, C value 2. That is the answer is option 4 is the answer. Okay, this is one of the applications of dimension analysis, and also the previous one, this principle of homogeneity questions, also there. Okay, yes, so this is all about dimension analysis. Then we can move to the next one as error in measurement. For example, in the question they are giving you the length of a physical quantity as 3 plus or minus 0.03 millimeter. Suppose this is the measurement given, the length measurement. Here, what about this 3 millimeter is the actual length. 3 millimeter is the actual length. And what about 0.03 millimeter is the absolute error, mean absolute error. It can be written as delta L, that is 0.03 millimeter. Okay, if this value is given to you, then what we understand, what is the percentage error in the length is? The percentage error in the length is delta L by L into 100. Delta L by L into 100, here it is 0.03 divided by 3 millimeter will be cancelled, and into 100. This is 3 by 3, how much it is? 1%. Okay. Now, what about this value? Suppose here there are 5 values of length measurement, L1, L2, L3, L4, etc. Then mean value of all these values, that is this one, mean value. Okay, and we are getting a mean value there. Okay, then this L1 minus L mean is the error in the first measurement. L2 minus L mean is the error in the second measurement. L3 minus L mean is the error in the third measurement, etc. And we are getting all the errors, and we are taking the mean value of all those errors, taking these errors as absolute values. Consider the absolute values only and take the mean error. That is this value, you understand that. That is written this one. Okay, this is the error. Okay, and what about the combination of error? The combination of error we studied. In the case of addition, we have to add the errors. Suppose if A is equal to B plus C, then what is the error in A is equal to error in B plus error in C. Now, in the case of subtraction, if A is equal to B minus C, here also we have to add the error. Error in A is equal to error in B plus error in C. Error should be added. Clear? If in the case of A is equal to B into C multiplication, then we find this relative error delta A by A is equal to delta B by B plus delta C by C. Okay. In the case of power coming there, if A is equal to B raised to N, then what is this relative error? Delta A by A is equal to N into delta B by B. We know that. Okay, and in the case of division, if A is equal to B by C, here also the relative error delta A by A is equal to delta B by B plus delta C by C. Addition. Clear? So this is combination of error in the case of addition, subtraction, multiplication, division. Combination of error. Okay, a huge chance of one question coming from this error. Okay, we can solve one question there. A metal wire has mass, this is the mass given, and radius given. Okay, then what is the true value of mass here? M is given 0.4 gram. And what is the mean absolute error? The delta M value is given 0.002 gram. Okay, and mean value of radius is R is given here 0.3 millimeter. Okay, and what is this mean absolute error in the radius measurement? 0.001 millimeter. Fine. And the length of the wire is given. The true value of the length of the wire is 5 centimeter. And that mean absolute error in the length delta L is given 0.02 centimeter. Okay, what is the maximum possible percentage error in the measurement of density is asked. Density. We know the density of a body is its mass divided by its volume. Okay, here this is the case of a metallic wire here. Okay, now mass divided by what is the volume is equal to pi r square into length. Pi r square into length, cylindrical volume. Okay, this is the density. Clear? Then we can combine the error as we studied in the previous case, delta rho by rho. Then delta rho by rho is equal to, here mass is coming in the numerator, delta M by M is there. Then divided by, so here plus should be there. Pi is a constant, no error in there. Then r square is there. R square, how we take it as 2 into delta r by r. 2 into delta r by r. Now here into is there, so again plus should be there. Error, relative error should be added. Then delta L by L. Delta L by L, okay. Putting the values, delta M is 0.002. Divided by M is 0.4. Okay. Gram cut. Then twice of delta R. Delta R is 0.001. And R is, what is R is 0.3. It is 0.3 plus. Then what about delta L? Delta L 0.02 divided by L is 5. Okay. Now, to get the percentage error, we have to multiply with 100. Okay. Then this will be multiplied with 100. We get 0.2 by 0.4. That is 2 by 4. That is 1 by 2. This is 1 by 2. This is in percentage. I am multiplying with 100, then converting into percentage. Okay, this is multiplied with 100 is 0.1 by 0.3, that is 1 by 3, then 2 by 3 here percentage, 2 by 3 here percentage. Okay, this is multiplied with 100 is 2 by 5 percentage, 2 by 5 percentage. Okay, then what will be the answer? The possible answer is this 1.6 percentage. We can easily add them to get 1.6 percentage. I think you understood that. Okay, lot of such questions possible. Okay, I hope you understood the concept of error. Okay, the combination of error. Yes, moving to the next one, significant figures. We know in a measurement given, suppose there is the measurement 5203.00. Suppose this is the measurement. Okay, then this 5 is significant, 2 is significant, 3 is significant, all non-zero digits are significant. Okay, then 0 between these two non-zero digits are significant. Okay, and if there is a decimal point, then these terminal zeros are also significant. Okay, suppose here it is the measurement 500 given, then there is no decimal point, then these two zeros are not significant, 5 is significant. Okay, now suppose this number is starting with a decimal point 0.08050. Now this zero this zero is not significant. Okay, not significant. Then what about this zero? Immediately after the decimal point, it is not significant. This 8 is non-zero digit, significant. This 5 is okay. Then what about this 0? Between two non-zero digits, it is significant. And what about this 0? It is the terminal 0 after a decimal point. After a decimal point, the terminal 0 is again significant. Okay, that's fine. Now how we represent the result of arithmetic quantities. Result of arithmetic quantities, that is another important. Suppose 1.2 plus 3.14 is equal to, okay, 1.2 plus 3.14, this is 4, then 1, 2, that is 3, 0.3 and 1, this is 4.34. But what should be the answer? The answer should be in terms of decimal place. Here the least number of decimal place is 2 out of these two. Here decimal place is 2, here it is only 1. Least number of decimal place is 1 only here, that is this one. Here it is 2. Okay, so the answer should also have the decimal place 1 only, that is the rule. Then we have to round this number to 1 decimal place, that is 4. Now we have to leave this, we have to drop this 4. It is less than 5, so it is dropped. Then the answer should be like this, 4.3. Understood? If it is 3.16, then here 6 comes. Then this 6 is dropped by adding 1 here. 1 here, that is 4.4. That we understood. Okay, that's fine. And suppose if this is 5 there, if it is 5 there, what we do? This one is 5 here, 5 here. Then what we do? Then here, what we do? So we have to restrict this as a single decimal point and this 5 to be omitted. Then we have to check whether this is odd or even. If it is odd, we have to add 1. We have to add 1 means 4.4 it is. Okay, if it is even, we have to leave this one without adding this if this number is even. Okay, that's the role of significant. That is the significant figure. We understood that. Clear? So very easy, that significant figure concept. Then screw gauge. Screw gauge is the length measuring device. Screw gauge is the length measuring device. There is a pitch scale here. This is the pitch scale. Listen, this is the pitch scale. There is a reference line. And over the pitch scale, we are having a head scale is there. Over the pitch scale, we are having a head scale is there. Head scale. This is the head scale. Okay. Okay. Over the head scale, these some divisions are there on the head scale, like these divisions are there. Divisions are there. And this reference line is there. On the reference line, there are values. On the reference line, there are values 0, 1, 2, 3, 4, etc. Okay, this is the screw gauge we studied. Okay, see, usually this 0 and 1 will be 1 millimeter usually. Okay, that is the one pitch scale division, usually one pitch scale division. And this head scale, there are just divisions are there. Usually it is 100. It is 100. Then usually what is the pitch of the screw gauge is the division value on the pitch scale, that is 1 millimeter divided by number of divisions on the head scale. Number of divisions on the head scale is 100. Okay. So usually what is this? This one is, see, this is not the pitch. This is the least count I am saying. Least count. Least count is equal to, I may give you the equation that pitch divided by number of divisions on the head scale. Okay. We studied that. Pitch divided by number of divisions on the head scale. What is the pitch is? This value is the pitch, 1 millimeter, 1 millimeter. And here if there are 100 divisions, then this is 100 and it will be 0.01 millimeter. This is the least count of the screw gauge usually, generally. And suppose they are giving you 0.5 millimeter is the pitch and 50 divisions are there on the head scale, then what is the least count? Least count is equal to 0.5 millimeter divided by 50. It is again 0.01 millimeter again. Okay. So it is the pitch value divided by number of divisions on the head scale. That is the least count of the screw gauge. And how we represent the reading of the screw gauge? The reading of the screw gauge reading is equal to main scale reading plus head scale reading into least count. Okay. Okay. Main scale reading plus head scale reading into least count. That is the final reading of the screw gauge. Okay. For example, here is a question. A screw gauge gives you the following reading when used to measure the diameter of a wire. Main scale reading is 0 millimeter. Here in the question, main scale reading is 0 millimeter. MSR is given 0 millimeter. Circular scale reading is 52. CSR is equal to 52. Circular scale reading is head scale reading. Both are same. Okay. Given that 1 mm on main scale corresponds to 100 divisions of the circular scale. Okay, that is the least count idea. 1 mm divided by 100, that is 0.01 millimeter. Fine. Okay. What is the diameter from the above data? The diameter from the above data is main scale reading plus circular scale reading into least count, very direct. Okay, main scale reading is here 0 millimeter, circular scale reading is here 52, and least count is 0.1 millimeter. So our answer is 0.52 millimeter. Remember this unit, millimeter. 0.52 millimeter is not there. This is centimeter given. So all these options are in centimeter. We have to divide this by 10. We get this is 0.052 centimeter. That also should be carefully listened. Okay, the final answer is in centimeter. Okay, and there may be error, zero error may be there. Okay, then this is actually the observed reading. This is the observed reading. And if there is a zero error mentioned, then the correct reading is equal to correct reading, actual reading. Correct reading is equal to observed reading minus zero error. Minus zero error. Okay. In this example, in the earlier example, there is no zero error mentioned here. Okay. That's why zero error is 0. So this is our answer. Okay. Suppose here they are mentioning minus 0.01 or minus 0.01 millimeter, zero error is there. Suppose they are mentioning minus 0.01 millimeter, zero error is there. Then what's our final answer is 0.52 minus zero error. 0.52, that is observed reading, minus zero error. What is zero error is minus 0.01. So 0.52 minus, that will be plus. Understood? Okay, then that will be 0.53 millimeter will be the correct reading. And if they are saying the zero error is plus 0.01 millimeter, then what's the actual reading is 0.52 minus zero error. What is zero error is this one. So we have to subtract this one from this. I think you understood this. And also another idea I will give you. If this reference line 0, if reference line 0 is above the head scale 0, there will be some head scale 0 will be there. Some head scale 0 will be there, then 10, then 20, then etc. up to 100 usually. Okay, this head scale 0 is there. So in this particular case, see, this reference line is above the head scale 0. That is positive error. Positive error. Listen that, and you can note that. Reference line above is positive error. If reference line is below the 0, suppose this is not the 0, this is not the 0, and suppose here is the 0 of the head scale, then the reference line is below. Reference line below means negative error. Negative error. Okay, clear? Reference line above the 0 of head scale is positive error. Reference line below the 0 of head scale is negative error. Okay, fine. Now, the next point is about vernier calipers. Vernier calipers. In vernier calipers also there is a main scale is there. There is a main scale. In main scale there are main scale reading is there. This is the main scale reading. This is actually as like the usual scale we use. Okay, in centimeter. Okay, and there are divisions of 1 millimeter. The usual scale we use. That's the main scale of this vernier calipers usually. So these are 1 millimeter. Okay, then here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1 centimeter, etc. This is the main scale of vernier caliper. Okay, and there will be a vernier scale will be there. There will be a vernier scale will be there like, let this be a vernier scale. This vernier scale can be slided over this. Okay, and there are divisions on vernier scale. Divisions on vernier scale. Generally, usually, this 9 main scale division, listen me, this one, how much divisions this is? 1, 2, 3, 4, 5, 6, 7, 8, 9. This 9 main scale division actually this is, what about this much length is 9 main scale division. And in this 9 main scale division length, usually there will be 10 vernier scale division. There will be 10. 1, 2, 3, 4, 5, etc. 10 will be there usually. Okay, I'm saying the usual situation, 99% situation. 9 main scale division is equal to 10 vernier scale division. This is the usual thing, which means that one main scale division is just greater than vernier scale division. You understood? What is one main scale division is 10 by 9 of vernier scale division. Okay, which means one main scale division is greater than vernier scale division. This is the usual case of vernier calipers. Okay, in this case, what is the least count of the vernier caliper is MSD minus VSD. MSD minus VSD. MSD Mahendra Singh Dhoni minus Virendra Singh Dhoni. Okay, MSD minus VSD is the least count of vernier caliper. Okay, this is the general equation. And suppose this one, generally I am writing this MSD is equal to NVSD. Then what is this? VSD is equal to, just listen me, VSD is equal to N by M of MSD. And put here instead of VSD, you will get least count is equal to MSD into 1 minus N by M. This is your equation to find the least count of a vernier calipers, MSD into 1 minus N by M. What is N? Is the number of vernier scale divisions which coincide with M main scale divisions. Okay, this is the least count. And what's the reading of this vernier caliper is? The reading of vernier caliper is written as the reading of vernier caliper. I can write there, the reading of vernier caliper is main scale reading plus vernier scale reading into least count. This is as it is. Main scale reading plus vernier scale reading into least count. Least count is obtained like this. Okay, main scale reading will be given in the question. Okay, vernier scale reading is the number of which division is coinciding with the main scale division. The number of vernier scale division which coincides with the main scale division, that is the vernier scale division. Okay, now come to this question. The main scale of a vernier calipers has n divisions per centimeter. Okay, in 1 centimeter there are n divisions. Okay, which means n main scale division is equal to 1 centimeter, that is given. Okay, then what about this main scale division is 1 centimeter divided by n. MSD is obtained. Okay, now n divisions of vernier scale, n vernier scale division is coincides with n minus 1 divisions of main scale. N minus 1 main scale division given in the question. What is the least count of the vernier caliper is this asked question, least count. What is the least count of this vernier caliper equation is MSD into 1 minus N by M. Generally we have written. And what about the MSD in this question is 1 centimeter divided by N into 1 minus number of vernier scale division. That is in this question also N divided by number of main scale divisions, that is in this question n minus 1. N minus 1. Okay. This is equal to 1 centimeter divided by n into n minus 1 minus n. Okay. That is, what about this one? See. This is number of, see here, n MSD is, here you can see this one. See, 9 MSD. Generally, 9, this MSD is less and VSD is greater. Okay, so that VSD is written in the denominator. VSD division is written in the denominator. VSD written. Actually, this is M by N. Actually, M by N. Listen that. M by N. This one is M by N. Okay, just listen. This is main scale division divided by vernier scale division. M by N. M by N. Least count is MSD into 1 minus M by N. Okay. 1 minus M by N it is. Isn't this? M by N. Okay. By heart it. M by N. Okay. In this question, what is this M is? The main scale division is N minus 1 here. It is N minus 1 here. And vernier scale division is N here. Okay. Now, What about this one? N minus n minus 1. That is n minus n is cut and it is 1 there divided by n there. Okay. Yes. Then what's the answer? Is centimeter divided by n square is the answer. Centimeter divided by n square is the answer. What is that? Centimeter divided by n square. That is option 4 is the answer. Okay. Fine. Now listen. This vernier caliper is also, these are the concepts, main concepts of units and measurement. Now we move into the next chapter, motion in a straight line. Come on. The important topics are kinematic quantities, that is position, displacement, velocity, acceleration. These are the kinematic quantities. And uniform motion is the motion with a constant velocity. Uniform accelerated motion is the motion with a constant acceleration. There are equations. Okay. Non-uniform motions there, okay, with varying acceleration, and the mathematics is in calculus form, and very less questions coming from this non-uniform motion. Okay. Motion under gravity is there. That is due to the effect of gravity, that is producing a constant acceleration g. So this motion under gravity is the case of uniform accelerated motion. So whatever equations here we use, all those equations are used here also. Okay. Then graphical study of motion, position time graph, velocity time graph. Okay, these are the very important two graphs there. Then acceleration time graph is there. Okay. Then relative motion. It's a very simple topic actually, relative motion. Okay. We can move into the topics. First one, kinematic quantities. Suppose this is a straight line. First we fix an origin. Then we are having different positions. Different positions we represented in terms of x. Okay. Suppose a body is moving here, an object is moving here. In this way means its x is varying as a function of time. Okay, for example, x is equal to 2t plus 5. For example, x is equal to 2t plus 5. Then what is its velocity? Velocity is dx by dt is the first derivative. It is just 2. Okay, now this motion, this particle is moving by obeying this mathematical relation means its velocity is 2 means it is a constant, means the motion of this body is uniform motion. Uniform motion. Okay. For example, in another case, for example, this x is varying as t square plus 4t. Then what about the velocity of motion is the derivative, first derivative, that is 2t plus 4. Okay. So velocity is changing. So this is not uniform motion. Then there is acceleration non-zero value. Once more differentiate it, we get this 2. Now this acceleration 2 is constant. It is constant means the motion, this particular motion of the object along this straight line is uniform accelerated motion. Okay, it's very simple. Now, so we understood this x value, then this velocity value, then this acceleration value. And what about the displacement? Displacement delta x is final position minus initial position. Okay, so between 2 second and 5 second in this particular motion, 2 second and 5 second, what is the displacement? Applying time as 5, then a minus here, then applying time as 2. Okay, it's very direct calculation, displacement. Okay, then what about this uniform motion? We already mentioned that is the motion with the velocity constant. Velocity as constant, this motion is called uniform motion. Then we have the equation of S is equal to, see, this is the displacement equation. V average into time interval. This is true in all situations. Study this one. V average is equal to displacement by time. Yes. V average is equal to displacement by time. Okay. Displacement by time. Then what is displacement is V average into time. This is the general equation. Now, in the case of uniform motion, you understand this V average value is equal to instantaneous value because velocity is constant. Velocity constant motion is uniform motion, then the average value and the instantaneous value will be same. Then we have the equation of uniform motion as S is equal to Vt. S is equal to Vt. This is the equation of motion. Okay. Generally, they are asking you the equation of V average. Then what you have to do is the total displacement divided by total time. Okay, average velocity questions are there. Average velocity questions are there. For example, see this particular motion of a body from A to B. In the first half of X, it is moving with a velocity V1. In the next half of X, it is moving with a velocity V2. What is the average velocity of this motion? Is very familiar situation, that total displacement by total time. See, what is the total displacement? Is x plus x. It is 2x divided by, what is the total time? From this to this, what is the time? Is x by v1. What is the time? What is the time? Is s by v. Look into this equation. Time is s by v. So what is this time from A to this point is x by v1. X by v1. Then from this point to that point B is, what is the time? Is x by v2. Is very, very clear. Then x will be cancelled. What is our equation? Is 2 divided by 1 by v1 plus 1 by v2. 1 by v2. Okay, that is 2 v1 v2 divided by v1 plus v2. Okay, we studied that. So this is the basic expression to find the average velocity. There are questions like a student is starting the journey from home to market, then from market to home again, etc. questions are there, and average velocity is asked. What's the basic point is? In that particular case, average velocity is total displacement by total time. That is 0, because the person is starting from a point and returning to the same point. What is the total displacement? Is 0. So the average velocity is 0. And suppose they are asking the average speed. Average speed means this is total distance divided by total time. Okay, so those questions of average velocity is there. It's very simple. And the equation of uniform motion is this: s is equal to velocity into time. Okay. Now what about this uniform accelerated motion? In the case of this uniform accelerated motion, suppose an object is moving along a straight line. From this point here, it is having a velocity u, and after time t, it is covered s displacement. It reached here. Now it is having a velocity v, and throughout the motion its acceleration is constant a. Then what are the equations? Final velocity is u plus at. These are very direct. And what is this? S is equal to ut plus half at square. Okay. S is equal to ut plus half at square. Okay. Then what is this? V square is equal to u square plus 2s. Okay. V square is equal to u square plus 2s. Okay. Now, what is this displacement in the nth second? These equations are very familiar. And what about the fourth equation? The displacement in the nth second. What is displacement in the nth second? Is u plus n minus half into a. Study this formula. U plus n minus half into a. Displacement in the nth second. Clear? U plus, for example, what is the displacement in the first second? Is u plus 0.5 a. What is the displacement in the second is u plus 1.5 a. What is the displacement in the third second? Is u plus 2.5 a. Okay, displacement in the nth second. This is the formula. Okay, I think you understood. And there is the typical situation of starting from rest, acceleration constant and starting from rest. Come on, starting from rest. This is a typical. If the question starts like this, the body is uniformly accelerating along a straight line starting from rest, then we should understand that this u is equal to 0. Okay, then our final velocity equation is at. Then what is our s is equal to half at square. Okay, what is our v square is equal to 2as. Okay, and what about the displacement in the nth second is n minus half into a. Displacement in the nth second is n minus half into a. Clear? Yes. Now this one is 2n minus 1 into a by 2. 2n minus 1 into a by 2. Sn. Okay, 2n minus 1 into a by 2. Okay. Now suppose the displacement in the first second and second second. What is the ratio? Displacement in the first second and second second are the ratio. Here you apply 1, a by 2 will be cancelled constant. Here you apply 1, then that is 1 is 2. Then here you apply 2, 2 into 2, 4 minus 1, that is 3. So this is 1 is to 3. Displacement in the first and second 1 is to 3. Otherwise, displacement in the first 2 second and the next 2 second is also 1 is to 3. Displacement in the first 5 second and next 5 second, this is also 1 is to 3. 1 is to 3. Okay. What is the condition? That acceleration should be constant and starting from rest. Okay. For example, I may give you this one. An object is starting from rest, uniformly accelerating. In the first 10 seconds, it travels 100 meters. In the first 10 seconds it travel 100 meter. In the next 10 seconds, how much it travels? In the next 10 seconds, it will travel 300 meter. Okay, because the ratio is 1:3. 1:3. Okay, these are very familiar ideas. I think you are very well aware of these topics. Okay, so these are the equations of uniform accelerated motion, and we are using these equations in vertical motion also. Vertical motion. Here is a question. A body starts from rest with uniform acceleration. Starts from rest, uniform acceleration. Velocity after n second is v. What is the velocity after n second is a into n? Velocity after n second is v is equal to an because u is 0. Then is displacement in the last 2 seconds. Last 2 seconds. What are the last 2 seconds? The final second is nth and the second last second is n minus 1th. Okay. So what is the displacement in the nth second is, what is the equation is? N minus half into a. N minus half into a. But here in the options when you see there is no a. Now you replace this a with v by n. Here you can see this a is v by n. Okay. N minus half into v by n. This is the displacement in the nth second. What is the displacement in the second last second is s n minus 1. Yes, n minus 1 is n minus 1 minus half into v by n. Okay, this is equal to 2n minus 1. 2n minus 1 divided by 2n minus 1 divided by 2. Okay, 2n minus 1 by 2 into v by n. Into v by n. And what about this one is n minus 3 by 2. See, it is n minus 3 by 2, isn't it? N minus 3 by 2. 2n minus 3. 2n minus 3 into v by 2n. V by 2n. What is the summation of this? V by 2n. V by 2n is common. V by 2n is common. Then 2n minus 1 plus 2n minus 3. Okay, that is 4n minus 4. This is 4n minus 4. The summation. Summation is 4n minus 4. Okay, then we divide with this 2n. Here it comes 2. Then what about this? 2 minus 4 by 2 is 2. 2 by n. Okay, what about this answer is v by 2n. What is the answer? You got this one. See, we can easily solve this again as v divided by 4n divided by 2n, it is 2 minus 4 divided by 2n, it is 2 by n. 2 by n. Okay, 2 is taken outside. 2v into 2v into 1 minus 1 by n. Okay, then n minus 1. Okay, 2v by n into n minus 1. This is the answer. You understood that? 2v by n into n minus 1. This is the answer. 2v by n into n minus 1 is the answer. That is option D. That is option D. Okay, you understood? So these are the questions, but we have to apply our formulas. Just only 4 formulas are there in uniform accelerated motion. And the same formula we are using motion under gravity also. In the case of this is non-uniform motion. What about the non-uniform motion? Those questions to solve, we use the calculus method. Calculus method. For example, this velocity is dx by dt. Listen me. Dx by dt. Then what about dx is v dt? Dx is v dt. Then what is this integral dx is the displacement, that is integral v dt. Integral v dt. Okay. This is to find the displacement. S is equal to integral v dt. Okay. Then also we have acceleration is dv by dt. Acceleration is dv by dt. Then dv is equal to a into dt. Then what this integral dv is v minus u. That is integral a dt. Integral a dt. Then what is the final velocity is u plus integral a dt. This is the final velocity. Final velocity is u plus integral a dt. Okay. But these questions based on these integrations very rarely asking. Okay. You focus on the other topics also. Okay, the other topics. For example, I may give you the question that v is equal to 2t plus 5. V is equal to 2t plus 5. V is equal to 2t plus 5. Okay, then how much is the displacement in the first 2 seconds? What is the displacement in the first 2 seconds? First 2 seconds means 0 second into 2 seconds. What is the displacement in the first 2 seconds? What is the equation of s is equal to integral v dt? Listen, integral v dt. S is equal to integral v dt. First 2 seconds is 0 to 2. Okay. Integral from 0 to 2. What is v is 2t plus 5. 2t plus 5. Okay. Then dt. Okay. What's this integration result is? Integral 2t dt is t square. Okay. T square by 2 into 2 is cut. It is t square. Okay. Then integral 5 dt is 5t. 5t. Okay, then 0 to 2 is applied. What is this? 0 to 2 applied means 2 square plus 5 into 2. 2 square is 4, then 5 into 2 is 10. 4 plus 10, that is 14 is the answer. 14 meter is the answer. 14 meters is the answer. And when we apply 0, the answer is 0. You understood? This is calculus method, very easily done. I think you understood this one. Okay. Okay. And what about this motion? You remember, this is not non-uniform accelerated motion. This is not non-uniform accelerated motion. This is actually uniform accelerated motion. Suppose if I put here 2, then what about this motion is non-uniform accelerated motion. But this method is again same. Here you have to put it 2. Okay. Then what this will be? 2 into t cube by 3. That will be 2 into t cube by 3. 2 into t cube by 3. Okay. Then here it is 5t. Then what this 0 to 2 is applied means 5 into 2 cube, that is 8. 2 into 8, that is 16 by 3 plus 5 into 2. That will be the answer. This won't be the answer. Okay. Whatever may be, this is uniform accelerated or non-uniform accelerated, you can use this basic formula. These are the basic formula. In any situation of motion, uniform motion, uniform accelerated motion, non-uniform motion, in any situation of motions, we can use these formulas. Okay, fine. Moving to the next concept is motion under gravity. In the case of motion under gravity, we can use those equations of uniform accelerated motion. For example, this object is projected with a velocity u vertically upward. During its upward motion, it is retarding. It is retarding. Its retardation is downward. This downward is represented by minus, and the amount of retardation is g. Okay, so it will be stopped after some time. Okay, what about this stopping distance h? Stopping distance h is u square by 2a. We studied u square by 2a stopping distance. Then there is g here. So this is the value of h. Okay, and what about this time of ascent? Time of ascent is the stopping time u by a. U by a is here g. Okay, a is here minus g, someone argue. What is the meaning of this minus is against the motion? Here means downward. This minus means downward. And the body moving upward and acceleration is downward means it is a retardation. And the amount of retardations to put here, that is g. This is time of ascent. And time of descent is also same thing. Then what is the time of flight is 2u by g. Time of flight value is 2u by g. These are the equations. Okay, and suppose they are asking you what is the velocity after 3 seconds. What is the velocity after 3 seconds? What equation we use? We use this equation v is equal to u plus at. We use this equation only, v is equal to u plus at. Okay, for example, an object is thrown vertically upward with 40 meter per second. 40 meter per second, I am asking you. An object is thrown vertically upward with 40 meter per second. What is this velocity after 3 seconds? What is its velocity after 3 seconds? U plus at. U is positive 40. U is positive 40 plus acceleration is negative g into time given to you 3. 40 minus 30. 10 meter per second is the positive value obtained. You understand that this body now at this end of 3rd second, it is moving toward, it is moving upward. This positive velocity still it is moving upward. Okay. If the question is about what is the velocity after 6 seconds, what is the velocity after 6 seconds, the same equation you use u plus at. U is positive 40, acceleration is negative 10 and time is 6. 40 minus 60, 40 minus 60 is minus 20 meter per second. Minus 20 meter per second it is. After 6 seconds. After 6 seconds, what is this? Is minus 20 meter per second. What's the meaning of this negative? Now the body is moving downward. Okay. So we have to use the basic expression, and remember these are vectors. This is vector, this is vector, this is vector. Okay. The direction should be properly applied. Okay. Then only we get the correct answer. I hope you understood that. Okay. So motion under gravity is fine. Now listen this question. A body thrown upward with some velocity reaches the maximum height of 50 meter. The maximum height h is given 50 meter. Maximum height is given 50 meter. Okay. Another body with the double the mass. Okay. Is there any influence of mass in maximum height? Is there any influence of mass in maximum height? Students, please answer. Is there any influence of mass? What is this? H is equal to u square by 2g, isn't it? H is equal to u square by 2g. Then is there any mass involved in this maximum height? No mass is involved here in this maximum height. Okay, no influence of this mass. With double the initial velocity, okay, doubling the initial velocity means maximum height is also changed. Okay, then what is the new maximum height is asked? We understand this maximum height is proportional to u square. Then final value divided by initial value is equal to final u by initial u the square. Final u by initial u the square. Final u is the double of initial. So this value is 2. 2 square is 4. I hope you understood that. Okay, u2 is twice of u1. Twice of u1 cut 2 square is 4. Okay, then this h2 is equal to 4 times of h1. 4 times of h1 given in the question as 50 meter. 4 times of 50 meter is the answer, 200 meter. Okay, these are very direct simple questions actually, isn't it? So this vertical motion is also finished. Now coming to the graph. Okay, what about graph? There position time graph is there. Position time graph. Suppose this is time t and this is x. Okay, this type of motion means there is no change of position, means the body is at rest. Body is at rest. And this is a constant velocity motion because the slope of this graph is dx by dt, that is velocity is constant here and positive velocity. Okay, and what about this motion is the slope of this particular graph is negative constant. Now the body is moving towards left with constant speed. Clear? Now this is a parabolic relation. This one parabolic relation means x is the function of t square. X is the function of t square means that is uniformly accelerated motion. Uniformly accelerated motion. And its speed is continuously increasing. You know, the slope at this point, the slope of the graph at this point and the slope of the graph at this point, when you compare, the second slope is greater means the second velocity is greater compared to this one means the speed is increasing. The speed is increasing and all these slopes are positive. Positive slope means positive velocity. Positive velocity means the body is moving towards right. Okay, this is about the position time graph. And what about the acceleration time graph? Before that, the velocity time graph is the velocity time graph. Okay, suppose this is the graph. What is the meaning is uniform velocity. Uniform velocity along the positive direction because this velocity is positive, isn't it? What about this graph represents? This graph represents the slope of this VT graph, that is acceleration is constant positive. Slope of this. Okay. What about this one is the acceleration is constant and negative, but the velocity values are positive. Velocity values are positive, but the acceleration is negative means retardation. There is a retardation. And what is the condition of retardation? Students, please understand that the condition of retardation is that velocity and acceleration should be opposite. Okay, for example, this particular segment of the graph, what about the velocity values are positive and what the slope, that is acceleration, is negative. So the body is retarding. You understand? What about this particular graph here? This particular graph here, what about this graph here? Accelerating or retarding? Accelerating or retarding, how we check? In this time interval, in this particular time interval, what about this graph is? These velocities are negative, negative velocity, velocities are negative and the slope is positive. Slope is positive, that's acceleration is positive, velocity negative means retardation. This is retardation, this graph is retardation. What is the condition of retardation? Again I am telling you, V and A opposite. If V is positive, A should be negative. If V is negative, A should be positive. That is a retardation. And what about this graph? See, in this particular situation, these velocities are negative and this slope is also negative. Velocity negative, acceleration negative, both are in the same direction. So in this particular time interval, the body is accelerating, speed is increasing. Okay, and what about this area of cross section? What about this area of cross section? What about this area of cross section? The area under velocity time graph is displacement. Area under velocity time graph is what? Displacement. So the displacement traveled by the body from this time to this time is this much area. From this time to this time for this particular motion is this much area. This much area. Okay, area under velocity time graph. Clear? So it's very simple. Now you check this question. Acceleration time graph of a body is shown. This is the acceleration time graph in which from this time to this time acceleration is positive constant. Now from this time to this time acceleration is 0. Clear? Now listen me, from time 0 to time t1, from time 0 to time t1, what about this acceleration positive? Means the body is accelerating. Okay, acceleration time graph of body is shown. Suppose the body is starting from rest. Okay, it's not mentioned here. Suppose the body is starting from rest, it's not actually mentioned. If it is starting from rest, means the speed is increasing from 0 to t1. Speed is increasing. Okay. Now from t1 to t2 what happens? From t1 to t2 there is no acceleration 0. Acceleration 0 means velocity remains constant. Velocity remains constant. So from 0 to t1 velocity increases. Then from t1 to t2 velocity remains constant. Then from t2 to t3, from t2 to t3 again acceleration is positive. Again velocity is increasing. Okay. So what's the graph here? Is this graph is true? This is not true. Okay, from 0 to some time its velocity is increasing, then velocity remains constant, then velocity decreasing, it is incorrect. Then what about this one is from 0 to some time velocity is decreasing, it is incorrect. And what about this one is from 0 to some time velocity is increasing, then velocity remains constant, then again velocity is increasing. So that is the graph, our answer is option C. Clear? The understanding of the concept. Okay. Yes. Now listen this relative motion. What about this relative motion? Okay, see, velocity of a body with respect to another body. What is the velocity of a body with respect to another body? Is velocity of A minus velocity of B. Velocity of A minus velocity of B. Now tell me, what is this velocity of A? Is the velocity of body A with respect to ground. And what is this velocity of B? Is the velocity of body B with respect to ground. Okay. Now what about the acceleration of body A with respect to body B? Is acceleration of A with respect to ground minus acceleration of B with respect to ground. What is the displacement of A with respect to B? Is displacement of body A minus displacement of body B. This displacement is with respect to ground, this is with respect to ground. Listen, suppose you and me are at 100 meters separated. You are 100 meters away from me, suppose. Okay. And I am observing you and I am finding that you are approaching towards me. And after some time we reached at my place and we are having our shake hand and we are discussing something, suppose. In this time interval, what is the displacement of you with respect to me? Is this 100 meter positive? I am considering this positive direction. You are approaching to me. Okay. So relative velocity of A with respect to B in this time interval is this 100 meter. But someone observing this motion from other frame. Okay. Suppose, listen me, I am in a train, you are also in a train. Okay. And the train is moving and someone is there outside observing us. Okay. Now, according to him, what is your displacement? According to him, your displacement will be different because the train is moving. But according to me, what is your displacement? You has just displaced 100 meters towards me. That is my observation. But according to the person outside the train, your displacement and my displacement are different. Okay, this is the concept of relative motion. And you can very easily understand this concept of relative motion by using some, practicing some problems. Okay, we may check any problems there. We may check. See, what about this problem? A student is standing at a distance of 50 meters from the bus. Listen that. A student is standing, this is the position of student and this is the position of bus, and the distance was 50 meter. 50 meter. Okay. As soon as the bus begins its motion, the bus begins its motion. Begins its motion means the velocity, initial velocity of the bus is 0. Begins its motion with an acceleration of 1 meter per second square. The acceleration of the bus is 1 meter per second square. 1 meter per second square. The student starts running towards the bus. Okay, means at a particular moment, the bus begins its motion. At the moment, the student starts running towards the bus. Fine. Now, with a uniform velocity u, the student is not accelerating, he is just keeping the uniform velocity and is given that u. Okay. Assuming the motion to be along a straight road, we already assumed, the minimum value of u so that the student is able to catch the buses. What is the minimum value of u so that the student able to catch the bus? Now listen me. Suppose we are in the bus and we are observing the motion of the student. Okay, and the student is approaching us with a velocity. Okay, for this student to catch the bus, what should be our feeling? We are in the bus. Our feeling should be that the student is approaching us. Okay, we are in the bus. Actually, the bus is moving, but for us, we are not seeing our motion. Okay, what is velocity of me with respect to me is 0. Okay, now I am observing the student and he is running towards me. So I am observing that he is approaching me. Okay, now after some time he just managed to catch the bus, means what his displacement according to me is this initial 50 meter. Initial 50 meter. You should understand. The displacement of student with respect to bus after the catching of the bus is that positive 50 meter. Okay, positive 50 meter. Yes. Okay. During this time, the velocity of the bus and the velocity of that student should be at least equal. The velocity of bus, actually the bus is accelerating, you know. Okay. So the student is approaching and catching the bus, and when he managed to enter into the bus, the velocity of the bus should not be greater than the velocity of the student. If the velocity of the bus is greater than the velocity of the student within this 50 meter, within this 50 meter, if bus is acquiring a velocity which is greater than the velocity of the student, then the student never can catch the bus. So what's our idea is, within this 50 meter, the velocity of the bus at least should be the velocity of the student, or should be less than the velocity of the student, never greater than, never greater than. The final velocity of the bus after this relative displacement of 50 meter should be at least equal to the velocity of the student. If the velocity of the bus is greater than the velocity of the student, then the student never catch the bus. This is the concept. Okay. So here the final velocity related, relative displacement related. Okay. Acceleration is there, initial velocity is there. Then what's our equation is connecting these quantities is v square is u square plus 2as. Okay. V square is u square plus 2as. This is our equation. Now I am applying the relative concept. Velocity of student with respect to bus, final velocity square. Initial velocity of student with respect to bus, square plus twice of acceleration of student with respect to bus into displacement of student with respect to bus. Yes. Then what is the final velocity of the student with respect to bus? Should be 0. Okay, I told you the final velocity of the bus and the student at least should be equal. Then only the student can catch the bus. Okay, so this relative value is 0. Okay, initial velocity of student, that is u, and initial velocity of bus, that is 0, plus twice of acceleration of the student. Acceleration of the student is 0, acceleration of the bus is 1. Then displacement of student with respect to the bus is positive 50. Positive 50. Okay. Okay. Now what about this term is minus 100. Taken to this side 100. 100 is equal to u square. U is equal to 10. Solved. Minus 100 taken to this side 100. 100 is equal to u square. Then u is equal to root of 110. It is solved. It is solved. What's the meaning? The student should have at least 10 meter per second velocity in order to catch the bus within this 50 meter relative displacement. The velocity of the student should be at least 10 meter per second. If his velocity is less than 10 meter per second, the student never catch the bus. This is the concept of relative motion. Okay, and you solve some more questions there, and You are having me there with you. You can ask your doubts there. Okay. Now moving to the next one is our next chapter is motion in a plane. Okay. This is also the part of kinematics, motion in a plane. The important quantities or all concepts are this one only. No other concepts there. Okay. Vectors. Basic idea. Kinematic equations in plane. That is, we are including the concept of vectors there. Okay. Actually, our equation earlier along a straight line, the uniform motion equation is S is equal to Vt. But while in the case of this plane motion, we introduce the concept of vector. Vector S is equal to vector V into T. Okay. Then we are having in the case of uniform accelerated motion, our equation V is equal to U plus AT. This is along a straight line. Suppose the motion is along a plane or in space. What we do here, we apply the concept of vectors. That is, vector V is equal to vector U plus vector A into T. Clear? So why, after understanding the concept of vectors, then solving these mathematical equations, very simple. Okay. Projectile motion is the star topic of motion in a plane. Okay. Then circular motion definitely is we cannot ignore that circular motion. And relative motion is also the relative motion. We already discussed the motion along a straight line like this. And there will be relative value, relative displacement of A with respect to B is velocity of A with respect to B into T. Okay. And when we introduce the concept of vector there, that is this topic, relative motion in this particular heading. Clear? So we can move into the topics. One is vector. Okay. So vector addition, we start with vector addition, vector A and vector B at an angle theta. Now, the point is how you check the angle between two vectors. The angle between two vectors is checked by the smallest angle when their tails are joined. This is their tails joined figure. And here one angle is this one, another angle is this one. Okay. Suppose this angle is 30 degree, then this angle is 350 degree. Okay. 330 degree. Okay. Total is 360 degree. Okay. 360 degree. Okay. Total is 360 degree. Okay. If this is 30 degree, this is 330 degree, then what is the angle between A and B? The angle between A and B is 30 degree. That is the smallest angle when their tails are joined, or the smallest angle when their heads are joined. When their heads are joined. Let this angle be 60 degree. Then what is the angle between these two vectors is 60 degree. The smallest angle when their heads are joined. Suppose this one is like this. And here is a angle given to you is 30 degree. What is the angle between A and B? Remember this. This is not the joining of tails or not the joining of heads. Okay. Then in order to make the joining of tails or heads, I am extrapolating this vector. This vector like this vector. Okay. This vector is now drawn like this. Now here is the joining of these two tails. These two tails joined, and this angle is the angle between the vectors. Okay. And this is given in the question as 30 degree, means what? This angle is 150 degree. This angle is 150 degree. So first of all, we understood how to find the angle between two vectors. How to find the angle between two vectors is okay. The smallest angle when their tails are joined, or the shortest angle when their heads are joined. Shortest is smallest. Okay, no problem. Now, what about the vector addition? Vector addition formula, let this be vector A, let this be vector B at an angle of theta between them. What is the resultant value is root of A square plus B square plus 2AB cos theta. Everyone in the world knows this. R is equal to root of A square plus B square plus 2AB cos theta. Now, a particular case, if A and B are equal in magnitude, suppose. If A and B are equal in magnitude, then your answer of this resultant vector magnitude is 2A cos theta by 2. By heart this, 2A cos theta by 2. A square plus 2A square cos theta. A square plus 2A square cos theta. 2A square common outside, 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. Okay, 2 into 2, 4 is root is 2. Then A square root is A. Cos square theta by 2 is root is cos theta by 2. Okay, okay. For example, this force F and this force F at an angle 60 degree. What is the resultant force? The resultant force is 2 into F into cos 60 by 2. Cos 60 by 2 is cos 30. Cos 30 is root 3 by 2. So this is root 3F. This is root 3f, root 3f. Okay. Studied? That's studied. And suppose if this is the vector A and this is the vector B at an angle theta between them, then what this resultant is vector A minus vector B. If this is the subtraction of the two vectors, then what is the value of their resultant value? We studied that root of A square plus B square minus 2AB cos theta. Minus 2AB cos theta, yes. A square plus B square minus 2AB cos theta. This is the magnitude of the subtraction. And remember, this theta is not the angle between vector A and minus vector B. This theta is the angle between vector A and vector B. Vector A and vector B, this theta, remember, look into this figure. Okay, fine. Now, if A is equal to B, you are subtracting two vectors of equal magnitude. You are subtracting two vectors of equal magnitude. You are subtracting two vectors of equal magnitude. Then what is the result? The result is not 0. You are subtracting two vectors of equal magnitude. The result is not 0. Or the result is 2a sine theta by 2. Remember this formula. 2a sine theta by 2. There are different situations of subtracting two vectors of same magnitude. Okay, 2a sine theta by 2. I will give you some idea. For example, this one is circular motion. An object was initially here. Then after traveling 60 degree, the object reached here. What is the magnitude of displacement? Let this be the radius r. Then this also will be r. Now what is the magnitude of displacement? Just solve there. Just solve there within 10 seconds. Okay, you understood the question? This is a circular motion. Two vectors of same magnitude. Okay, two vectors of same magnitude. That is the what it is. The magnitude is r. Okay, and what's the angle between them is 60 degree. Okay, see what is this displacement is from A to B vector. From A to B vector, this is the displacement. This is delta r. So here this vector delta r is the final vector I am putting as r dash minus initial vector. Okay, so these two r dash and r are having same magnitude. They are having same magnitude. So what is this magnitude is 2 into r into subtraction. So what is sine theta by 2 into r into sine theta by 2. Okay, then what about this sine 60 by 2 sine 30? Sine 30. What is sine 30 is 1 by 2. 1 by 2 into 2. That is 1 into r. So the answer is r. And it is expected because it is 60 degree. And this r same means this will be also same. This is 60 degree, this is 60 degree, this is equilateral triangle. We are. Okay, from this point to this point, what is the angle theta is 90 degree. What is theta by 2 is 45 degree. Then what is sine 45 is 1 by root 2. Then what is 2 by root 2 is root 2. Then what's the displacement is root 2r. Okay. Suppose the 120 degree angle is traversed from A to this C. It is 120 degree angle traverse. What's the magnitude of displacement? What the equation is 2r into sine 120 by 2, sine 60, root 3 by 2, 2 cut, root 3 into r. What's the displacement is root 3 into r. Understood? Yes. Okay. So this is the vector subtraction. Okay. And also we are having the dot product and cross product. What about this vector A dot vector B is equal to A into B cos theta? A into B cos theta or B into A cos theta? Okay, A into B cos theta or B into A cos theta. And what about this A cross B? This just we are revising the formula. A cross B is magnitude is AB sin theta. Its magnitude is AB sin theta. And what about its direction is understood from right hand thumb rules. Very simple to find the direction of cross product by using this right hand thumb rule. Okay, right hand thumb rule is very easy. Right hand thumb rule. Okay, A cross B. Yes, that about vectors. Okay, now two forces each equal to F act as shown in the figure. Listen, that is the figure. Their resultant is, okay, what about the resultant? Listen, this head and this tail joining at 60 degree angle. So we extrapolate this direction. This direction, now these tails are joined. Then here 60 degree means the remaining angle is 120 degree. 120 degree. And remember, these two vectors are of same magnitude. This is F and this is also F. You understood? This vector is redrawn here like this. So they are having same magnitude. Then what is the resultant if the magnitudes are same is 2F into cos theta by 2. Okay, adding, so it is cos theta by 2. Adding, cos theta by 2, subtracting, sin theta by 2. Okay, 2 into f into cos of, what is theta? It is not 60 degree. What's the angle here between these two vectors is 120. Then 120 by 2 is 60. Then cos 60. Cos 60 is 1 by 2. 2 and 1 by 2 cut. The answer is F. Answer is F. Where is F? The answer is B. Option B. Clear? Very simple. These questions are asking. It's very simple. No problem. Come on. Now kinematic equations. Kinematic equations, nothing. This vector is vector v into time t. This is the case of uniform motion. This is the case of uniform motion. Uniform motion. This is the case of uniform motion. Yes. And now this uniform accelerated motion equations are there. That is vector v is vector u plus vector a into t. Okay. Then what about this vector s is vector u into t plus half into vector a into t square. Okay. Okay, the next equation is a scalar product equation, so I am not writing that. These are the equations. For example, I may give you one question that let the initial velocity be 2i cap plus 3j cap and the acceleration be 3j cap plus 4k cap. Okay. Find the velocity after 2 seconds. Find the speed after 2 seconds. For example, what is the speed after 2 seconds? Find the speed after t is equal to 2 seconds. Find the speed after t is equal to 2 seconds. Remember this motion, whether it is uniform motion or uniform accelerated motion. Can you say? Whether it is uniform motion or uniform accelerated motion. Here this acceleration is a constant. There is no time involvement. There is no time involvement. So this is uniform accelerated motion. So what equation we use here, that final velocity is equal to initial velocity plus acceleration into time. Okay, what is initial velocity is 2i plus 3j plus what the acceleration is 3j plus 4k. 3j plus 4k into time t is 2. Okay, this is 2i plus this is 3j and 2 into 3j 6j. 6j and 3j is 9j. 9j. 4 into 2, that is 8k. Okay, this is the velocity vector. Velocity vector. I asked you about the speed. What is the speed? Is the magnitude. Speed is the magnitude of velocity, that is root of 2 square plus 9 square plus 8 square. Okay, this is the answer. You solve that, you will get the answer. I think you understood this. So the same earlier equation we use here, but the treatment is the treatment of vectors. Vector treatment is done. Okay, vector treatment. Fine. Come on. Now what about the projectile motions? Projectile motion is an example of motion in a plane, and anything is thrown into the gravity and there is only gravitational force, no other force there, then the motion is called a projectile. I am thrown this marker and there is no air friction or anything, and only force which is governing the motion of this marker is gravity, then we call its motion as projectile motion. My question is whether the projectile motion is an example of uniform accelerated motion or not. Your answer is it's an example of uniform accelerated motion, because throughout its motion consider this x-axis, this y-axis. Okay. Now a body is projected from this point considered origin. Okay, it is thrown like this, so its motion is parabolic. Okay, the motion of the ball is parabolic. Okay, okay, the batsman hitting the six and the trajectory is parabolic. Okay, now see, throughout its motion, this is the motion of the ball. This is a maximum. Okay, maximum in IPL. Nowadays IPL is going on, and maximum hit. Okay, throughout the motion the acceleration is minus g. Throughout the motion acceleration is minus j. Acceleration is minus j. Acceleration is toward the it is toward the center of the earth and its value is g. So this motion is an example of uniform accelerated motion. So we can use the equations of uniform accelerated motion. That's it. Okay. Now some equations we already derived, just mentioning here. This body is projected with an initial velocity of vector u. Let this angle be theta. then you can resolve this. This is u cos theta. This is taken as the x component of initial velocity, and this is the u sin theta, and this is taken as the y component of initial velocity. Okay. Now the path of the projectile is parabolic. Okay. Now my question, what is the equation for a time of flight? The equation for a time of flight is twice of uy by g. Twice of uy by g. Twice of uy by g. That is equal to 2u sin theta by j. Fine. What is the equation for maximum height? Maximum height equation is uy square by 2g. Maximum height equation is uy square by 2g. That is equal to u square sin square theta by 2g. Okay. What is the equation for horizontal range? Horizontal range is 2ux uy by g. 2ux uy by g. 2ux uy by g horizontal range. It is equal to u square sin 2 theta by g. U square sin 2 theta by g. Okay. These are the equations. For example, I am giving you this vector u is equal to 40 I cap plus 50 j cap. Okay. And I am asking you the time of flight, maximum height, horizontal range. Okay. Answer. What this time of flight is twice of uy by g, I told you. Twice of uy here is 50 by g. G is taken as 10, so this is 10 second. Okay. What is the maximum height? Then your answer is uy the square divided by 2g. Okay. uy is 50, its square is 50 into 50 divided by 2 into g is 20. Okay. 5 into 50, 250 by 2 is 125 meter. Okay. And what is the range value is twice of ux into uy by g. Okay. Twice of ux is here 40, uy is here 50, g is 10, 0, 0 cut. 2 into 50 is 100 into 4 is 400 meter. Okay. Okay. So in certain questions they are giving you like this type of vector formula. In that vector formula I will get the answer. Okay. Yes. Clear. Now listen. See. What about this question? The maximum height attained by a projectile when thrown at an angle theta with the horizontal is found to be half of the horizontal range. The maximum height attained by a projectile, that is actually the question. What is the maximum height attained by a projectile? Now, what is the maximum height attained by a projectile when thrown at an angle theta with the horizontal is found to be half of the horizontal range. Okay, the maximum height h is found to be half of the horizontal range. Okay, fine. Now, what is the value of theta is asked. Listen this, h is equal to uy square by twice of g. Okay, and this range r is equal to twice of ux uy by g. Okay, now what about this r by h? R by h. 2ux uy by g into reciprocal 2g divided by uy square. Okay, g cut. Okay, 2 into 2 4, then 1 uy is cut, then ux divided by uy. Okay, 4 ux divided by uy. Okay, look into this figure. Where is that? Look into this figure. Yes, this figure. Listen, what about this tan theta in the figure is very clear. This opposite side by adjacent side, that is uy by ux. Tan theta is uy by ux. Tan theta is uy by ux. Tan theta uy by ux. Then what about ux by uy is 1 by tan theta. So it is 4 by tan theta. R by h. R by h is 4 by tan theta by heart. R by h is 4 by tan theta by heart. R by h is 4 by tan theta. R by h is 4 by tan theta. Okay. R 4. R by h is 4 by tan theta. Okay. Now here you check this one. What is the R by h here in this question? R by h is here 2. That is R by h is 4 by tan theta. 4 by tan theta is 2. Okay. Then what about this tan theta is 2. Okay. Tan theta is 2 and 4 cut and tan theta is 2. Okay. What is theta? Tan inverse of 2. Theta is tan inverse of 2. Actually, this is inverse. Okay. Tan inverse of 2. Answer option A. Tan inverse of 2. Yes. Option A. Clear? This is the answer. Clear? It's very dark. So this one is the relation between R and H. Okay. Maximum horizontal range and maximum height. R by H is 4 by tan theta. Okay. Okay. Lot of questions are there from projectile, and we have mentioned certain equations like this. Certain equations like this. These are the main equations there. Study all these equations there. Okay. And one important point, during this horizontal motion is influenced by any force, not influenced by any force. That's why this horizontal velocity remains constant. Horizontal velocity remains constant. And what is the velocity at the highest point is this u cos theta. U cos theta remains fixed. Okay. But this u sin theta will be changed. And it's reduced, and here it is 0, then inverted. Okay. So vertical velocity is changed, but this horizontal velocity is not changed. Horizontal velocity is okay. Okay. In which case R maximum and minimum. R minimum is just you throw this one like this. Okay. Venkat. When you throw the body like this means that R is 0. Okay. That when theta is 90 degree. When theta is 90 degree, R is minimum. And when theta is 45 degree, R is maximum. Okay. When theta is 45 degree, then this will be sin 90 and that will be R maximum. Okay. R will be maximum. What is this? R maximum. R maximum is equal to u square by g. U square by g. It happens when theta is equal to 45 degree. Okay. You throw the ball at an angle of 45 degree from the horizontal. Your horizontal range will be maximum. Here 2 into 45, 90. Sin 90, that is 1. Okay. And if this theta is 0, it will be sin 0. Then what is the range is 0. That is the minimum range. Okay. Suppose you are throwing your shot put just vertically upward, means that shot put will be falling on your head. Okay. And what the range there is 0. That's the minimum range when theta is 0 degree. Okay. Now that is the vector concept, and we are almost done with vector concept. Now this circular motion. Okay. What about the concept of the circular motions here? Okay. This is a plane. This circle is considered a plane. So again the motion of the body is along a circle. The motion of the body is along the circle. Okay. Here its position vector r is varying, and also here an angular parameter is there, that is theta. This theta is also varying there. Theta is also varying there. Okay. Now this first derivative of theta, d theta by dt, this is known as angular velocity. This is known as angular velocity omega. Angular velocity omega. Okay. Angular velocity omega. Yes. And when this d theta, this angle is 2 pi, and then this time interval is called a time period. Then we have omega is equal to 2 pi by t. Okay. And this 1 by t we call it as a frequency, 2 pi nu. Omega is called a frequency. Okay. And if the motion is with uniform velocity, if the motion is with uniform speed, it is called a uniform circular motion. Okay. Now in this case of uniform circular motion, my question is whether the velocity is changing or not. Your answer should be the velocity is changing. The velocity is changing because the direction of velocity is changing. Okay. Whenever there is velocity changing, that there will be acceleration. Okay. There will be acceleration will be there. Okay. So the acceleration is toward the center of the circle. Okay. And this acceleration is called centripetal acceleration. We studied. And what about that centripetal acceleration formula is v square by r. Centripetal acceleration formula is v square by r. Okay. And if there is any tangential force, then the speed will also be changing. If there is tangential force, then the speed also will be changing. Okay. If there is no tangential force, then the speed remains constant, but the direction will be changing due to this centripetal acceleration. Okay. So the centripetal acceleration is provided by some force. That force we call it as centripetal force. Okay. Okay. This is the basic. And earlier we have discussed that what is the equation of the displacement. Okay. During its motion, if this radius vector is creating an angle theta there, what the displacement is 2r sin theta by 2. 2r sin theta by 2. 2r sin theta by 2. Okay. And suppose this is uniform circular motion, means the velocity is having same magnitude. Okay, then suppose they are asking what is the magnitude of change in velocity. What is the magnitude of change in velocity? The displacement already we discussed 2r sine theta by 2. Sine theta by 2. And what is the magnitude of change in velocity? Magnitude of change in velocity is 2v sine theta by 2. 2v sine theta by 2. Okay, in the case of uniform circular motion, magnitude of the change in velocity is 2v sine theta by 2. That is also can be asked. Okay, this is a quick revision of circular motion, this omega relationship. Okay, and usually this frequency they are mentioning in RPM. RPM. Okay, for example, 300 RPM, 300 rotations per minute. 300 rotations per minute means how many rotations in 1 second? 300 by 60. 300 by 60. This is 300 by 60 hertz. Hertz. Hertz is the SI unit of frequency. 300 by 60, that is 5 hertz. 5 hertz. Okay. If an object is in circular motion with 900 RPM, what is this omega? What is this omega? Omega is 2 pi into nu. 2 pi into what is this frequency is 900 RPM. RPM converted into hertz by 60. Okay. Then what about this? 90 by 6 is 15. Okay. 15 into 2 is 30. 30 pi. 30 pi. Rad per second is the SI unit of omega. Rad per second is the SI unit of omega. Okay. RPM value is there. RPM value. RPM value. RPM value, how it is converted into hertz? By multiplying with dividing with 60. Okay, fine. So that is all. When a ceiling fan is switched on, it makes 10 rotations in 4 seconds. How many rotations will it take in the next 4 seconds? We discussed this in the case of motion along a straight line, that the displacement in the first t second is to in the next t second. Displacement in the first t second and in next t second. 0 to t and t to 2t. This ratio is 1:3 we studied. Okay. If the object starts from rest, and uniformly accelerating, then the displacement in the first t and next t are in the ratio 1:3. Now consider the situation of circular motion. Circular motion starting from rest. Circular motion starting from rest, and it is uniformly angular accelerating. Uniformly angular accelerating. The number of rotations in the first t and in the second t. Number of rotations in the first t and the second t will be in the ratio 1:3. Will be in the ratio 1:3. Okay, in the first t second how many rotations is to, in the next t second how many rotations will be in the ratio 1:3. That is yes, 30. 30 is the answer. See, here it is number of rotations. In the first 4 seconds 10 means in the next 4 seconds 3 times. Yes. Next 4 seconds 3 times. 3 times means 30. 30 is the answer. 30 rotations is the answer of this particular question. So keeping this ratio is highly useful. Clear? Okay. Now relative motion. See, the motion, the relative motion here is the usually the crossing of boat, etc. Relative motion, crossing of boat. So we can use, we can solve a problem there. The speed of a swimmer in still water is 20 meters per second. The speed of a swimmer in still water is 20 meters per second, considering crossing of a river. Suppose this is a river. Okay. Then the speed of the swimmer in still water. This is, you should understand, velocity of swimmer with respect to water. Velocity of swimmer with respect to water. That is this data in still water. Okay. With respect to water. That is given 20 meters per second. Okay. The speed of river water is 10 meters per second. The speed of water is here 10 meters per second. Okay. And it's flowing due east. Let this be east. Then this is west. This one is towards north and this one is towards south. Okay. If he is standing on the south bank and wishes to cross the river along the shortest path. Yes. Along the shortest path. Okay. The crossing is along the shortest path. Okay. From the south bank to along the shortest path. This is the shortest path. Okay. For this particular crossing, he has to swim in this direction. Okay. This is the velocity of swimmer with respect to water. Plus this is the velocity of water. The resultant of these two is in this direction. This is the velocity of swimmer with respect to the ground. This velocity of swimmer with respect to the ground. You understood? You understood? This velocity of swimmer with respect to water plus velocity of water. What is this? What is this vector? Velocity of swimmer minus velocity of water plus velocity of water. That is velocity of swimmer. This is the relative. Understood? So this is how the swimmer is swimming when we observe from the ground. With respect to ground. We are looking the swimmer from the ground. So it is appeared that the swimmer is just crossing the river along the shortest path. Okay. So what is this angle? What is this angle he should make? Okay. From the north direction. The angle at which he should make his strokes with respect to north direction is this angle. Okay. So the velocity of water is 10 and velocity of swimmer with respect to the water is 20. So very clear, what about this sine theta is opposite side divided by hypotenuse. Sine theta. Then what about this is 1 by 2, which means theta is equal to 30 degree. Theta is equal to 30 degrees. Very clear. So 30 degree towards west. 30 degree towards west. This one. From north direction, he should make his strokes at an angle of 30 degree towards west. Understood? So the answer is option 1. Okay. This is one example of relative motion. Yes. Okay. Now, we can move into the topic of laws of motion. The important topics here are this first law of motion, that is the law of inertia. The second law of motion is called the law of force. The third law of motion is called the law of action and reaction. Then tension and normal reaction, a typical topic. Some contact force, tension, normal reaction and friction. Friction is there. Okay. Then centripetal force, that is the case of circular motion, typically along a curved road or at the end of a string, etc. These are the problems here. Okay. And vehicle in a curved road. Vehicle in a curved road, what about the safe speed, maximum, safe speed, etc. Okay. Yes. Then the first law of motion is the law of inertia. Every object continues in a state of rest or of uniform motion along a straight line unless compelled by an external force. Okay. So in order to change the state of a body, some external force should act on it. That's the point. That is the law of inertia. It is called the first law of motion. Okay. Nothing there else. Then second law of motion. Then what about that external force? That external force is derived by dp by dt. This is the external force. External force. Vector dp by dt. This is the external force. And this statement is called second law of motion. Okay. The external applied force is the rate of change of momentum. Okay. And the momentum change and applied force are taking place in the same direction. Okay. Now here this is d by dt of linear momentum is mass into velocity. Mass into velocity. Majority case 99.9% situation of problems just like mass constant. Okay. So mass is taken and what is dv by dt is acceleration, as this is the well-known famous formula for force in terms of mass and acceleration, F is equal to ma. Okay. And there are certain other situations also in which mass is varying and velocity remains constant. For example, a balloon is blown and it is made free. Now it is moving forward because of the air is rushing backward. Okay. The air rushes backward with a constant speed. Now the mass of the balloon is changing. Okay. So what is the thrust which is responsible for the acceleration of the balloon? In that particular case, mass is varying, so there is dm by dt. And the velocity is constant. Then v into dm by dt is the thrust there in that particular case. V into dm by dt situation. And remember, this dm by dt is the ejection of mass per second. Okay. dm by dt is the ejection of mass per second. Okay. Okay. For example, the air is rushing at a speed of 10 meters per second, and in 1 second, suppose some 1 kilogram mass of air is rushed out. In 1 second, 1 kilogram mass of air rushed out and at a speed of 10 meter per second means 10 into 1, 10 Newton is the force. 10 Newton is the thrust acting on the balloon at that moment. Yes. Okay. So that situation is also there. But the usual situation in which, for example, this is a smooth floor, there is an object, okay, now it is having mass 2 kilogram, it's having mass 2 kilogram. Suppose it's accelerating by 2 meter per second square, 2 meter per second square, then this is a smooth floor, then what should be the force acting on it is very direct. What should be the force acting on it is mass into acceleration 2 into 2, 4 Newton. Okay, 4 Newton. Okay, that is this formula. Clear? Second law of motion. And what about the third law of motion? Force always exists in pair. Force always exists in pair. Consider an object resting on a floor. Okay. Now, the gravity acting on the body in this direction. Okay. What about this force? This is the force by the earth on the body. Okay. Then there will be the force on the earth by the body. That will be in this direction. And these two forces will be same, mg. Okay. This is action, this is a reaction. What about this force? Very calm and quiet, you listen that. This force is the force on the body by the earth. What about this force? This is the force on the earth by the body. Okay. But we observe that the body is accelerating down. We are not observing the earth is accelerating up. Why? What about this acceleration is force by mass? The force is same in both cases. The force on marker and the force on earth, same. But what about the mass? The mass of marker is less, very less. Then this acceleration is much great. The acceleration of marker is much great. And the acceleration of the earth is almost zero. Yes. Okay. Now here another pair I can show you that. There is normal reaction acting on the body from the ground. Listen. Normal reaction acting on the body from the ground. Then there will be normal reaction acting on the ground from the body. Normal reaction acting on the body on the ground from the body. Okay. And this also will be same in magnitude. Listen carefully. What about this normal reaction? On the body by the ground. What about this normal reaction? On the ground by the body. Okay. Okay. Yes. Okay. Suppose I am asking you this question. This body is of mass 2 kilogram. Okay. How much is the normal reaction? How much is the normal reaction on the ground by the body? By the body. Can you answer? How much is the normal reaction on the ground by the body? Answer is equal in magnitude as that the normal reaction on the body by the ground. Okay. Normal reaction on the ground by the body is equal in magnitude of normal reaction on the body by the ground. Magnitude. I am speaking about magnitude, not about the direction. And this one is equal to mg because, see, we understood this body is in equilibrium. Listen carefully. This body is in equilibrium means the net force on the body is 0. Net force on the body is 0. What are the two forces on the body? One force is the gravitation mg. The other force is the normal reaction m. Now listen me. This is action, this is the reaction. No. This is the force on the body. This is also the force on the body. Okay. These two forces are acting on the same body. Okay. And it is in equilibrium means net force 0. Net force 0 means this force and this force should be equal. That's why I am written that this normal reaction is mg. And the mass of the body is 2 and g is taken 10, then 2 into g, that is 20. Okay. So what was my question? How much is the normal reaction on the ground by the body? That is equal to the normal reaction on the body by the ground, and its magnitude is 20 Newton. Done. 20 Newton. This is about normal reaction. Okay. And also there is Newton's third law is also involved. Listen. Suppose here this is the wall. Okay. We are pressing this block by using F force. Okay. So this block is pressing the wall by F. Okay. Then the block will press the ball by this same F. These are equal in magnitude, opposite direction. This is action and this is reaction, or vice versa. You understood? I think you understood that. Okay. What about this force is? What about this force is? What about this force? I am representing this force is. This is the force by the block on the wall. And what about this force? This is the force on the block by the wall. And these two are equal and opposite. That is Newton's third law of motion. I hope you understood that. Okay. Now tension on a wire. Tension on a wire. Consider two blocks M1, M2. Okay. We are applying a force here. F. Okay. So that the system is accelerating by A. Clear? Now listen. What about the tension acting on the rope? There is tension T in this rope. Okay. But this tension T acting on this body in this direction. Okay. And the tension T acting on this body in this direction. Okay. Along the same rope, same tension. Okay. So on this body, this is T, and on this body, this is also T. Okay. And the tension acting away from the body. Tension is acting away from the body, away from the body, away from the body, away from the body. Okay. Yes. Listen. Now, when you write Newton's second law here, how can you write? Let this mass be M1, let this mass be M2. Okay. When you write Newton's second law here, what do you write? What is the net force on it is F minus T is equal to M2 into A. M2 into A. Then how you write Newton's second law on this body? What is the only force acting on this in the horizontal direction is T is equal to mass into acceleration, M1 into A. Okay. Here. So here this F minus M1 into A is M2A. Then what is F is equal to M1 plus M2A. Okay. So what is the acceleration of this system is the applied force F divided by total mass M1 plus M2. Is the acceleration of the system. Clear? So tension, what is the concept? Tension acting along a rope will be same at the 2 points and will be away from the body, away from the body. Okay. Now, consider this figure here. The block A in figure weight 100 Newton. The coefficient of static friction between the block and the table is 0.25. Here is the coefficient of friction is 0.25. Coefficient of friction. Okay. The weight of the block B is maximum for the system to be in equilibrium. Okay. For the system to be in equilibrium, this weight is now maximum. If we increase this weight, there will be sliding here. Okay. As of now, there is no sliding here. Okay. Now, what is the value of T1 is asked? The value of T1 is asked. The value of T1 is asked. Listen. Here is the contacting point. Here is one string, here is another string, here is another string. Okay. And let this tension is T2. Okay. And here it is 45 degree. Then this component is T2 cos 45. T2 cos 45. And this is T2 sin 45. T2 sin 45. Okay. This T2 sin 45 is balancing the weight of the B. And here is the A. It is just to slide here. Just to slide here. Okay. Then here is tension T1 acting here. And that tension here also acting in this way T1. Okay. Now what about this T1 and T2 cos 45 will be equal. And this is just about to slide. Okay. Then we can easily understand that this T1 value is equal to T2 into cos 45. We can easily understand that. Okay. If T2 is asked, we can use this equation. But they are asking only the value of T1. So I can apply here. What about this T1? Listen me. This is enough force just for the sliding of this block. Just for the sliding of the block means this is Fs maximum. Maximum static friction. And maximum static friction is mu s into normal reaction. Mu s value is given 0.25. 0.25 is 1 by 4. 1 by 4. And normal reaction is here weight of the body. What is the weight of the body? Is 100 Newton. Weight of the body 100 is cancelled by the normal reaction 100. 100 by 4 is 25 Newton. Okay. So 25 Newton is the value of T1. 25 Newton is the value of T1. Then what should be the weight of the body? That can also be asked. What is the value of T1 is now obtained 25 Newton. That is equal to T2 cos 45. Then what is this? T2 is equal to 25 divided by cos 45 1 by root 2. That is 25 root 2. T2. 25 root 2. This is 25 root 2. And into sin 41 by root 2, that is root 2 cancels, that is T2 is also 25. So what is the maximum weight of the bodies? That is T2, that is also 25. So different questions can be asked. And we are using our concepts to solve this question. Okay, never we are by hearting the answers or anything. We are just understanding the concepts. Okay, so maximum you try to focus, okay, and try to understand the concepts, applying these concepts in the exam hall. Clear? And we are having further 4 or 5 days there before the NEET examination. Okay, you can ask your doubts. Okay, you practice the questions regularly and ask me the doubts and solve the maximum possible physics question there. And our aim is 700 plus out of 720. Okay, it is no crime to aim this 700 plus. Okay, that's our right. Okay, moving to the next one is normal reaction. Normal reaction, about normal reaction we explained already about normal reaction. Here we can solve a question. A body of weight 50 Newton placed on a horizontal surface is just moved by a force of 28.2 Newton. Okay, this is just moved by 28.2 Newton. Listen, this is the body. Okay, and this is the force 28.2. Here is 45-degree angle mentioned. Okay. Then what about this component is 28.2 into cos 45. Cos 45. Okay, this component. That is 28.2 divided by root 2. Okay. 28.2 divided by 1.41. Okay. This is equal to 20. Listen. This is equal to 20 Newton. Okay. So this force here we obtained it as 20 Newton. Okay. This is just for the block to move. Its weight is 50 Newton. Here given 50 Newton. That is balanced by this normal reaction. Balanced by this normal reaction. This 50 Newton is balanced by this normal reaction. Okay. 50 Newton. Fine. Now, the frictional force and the normal reaction are, okay, it is just about in the moving mean this 20 Newton is cancelled by this frictional force. So what about this frictional force obtained is 20 Newton. Frictional force is 20 Newton. That is the only option there. Okay, 20 Newton. Yes. And what about normal reaction? See this normal reaction N, and there is one more force, this 28.2 into sin 45 is in this direction. Listen properly, you understand. What about this component of this force is 28.2. 28.2 into sin 45. 28.2 into sin 45. What is that? Is equal to again 20 Newton. Okay. So this upward direction, that is 20 Newton plus N. That is balance in this 50. You understand? What is balance in this 50? This N plus 20. N plus 20, that is balance in this 50. So what about the normal reaction is 50 minus 20, that is 30 Newton. You understand? This 28.2 is resolved into this component and this component. This component is obtained 20. This is 20, so this is also 20 because the angle is 40. This is 20, this is 20. Okay. Then 20 plus N is balancing 50. So N is 30. We understood? N is 30. We understood. Okay. Students, right now we are taking a short break. Okay. After the next 10 minutes, we will be coming back and we'll be discussing the rest of topics of laws of motion. Then again, we are having work energy power, gravitation, rotation, thermal, etc. Okay, we will having this quick revision of the topics. Okay, so stay tuned there after 10 minutes. Have a tea break. Thank you. Okay. Okay, let's continue. Okay, listen. So this is the question about this normal reaction and this frictional force. Okay. What about this question? See, two blocks of mass 7 kg, two blocks of mass of 7 kg and 5 kg are placed in contact with each other on a smooth surface. This is a if a force of 6 Newton is applied, 6 Newton is applied on the heavier mass. What is the force on the lighter mass? What is the force on the lighter mass? See, here there will be a force on the lighter mass. Actually, this is contact force, normal reaction. Okay, normal reaction on 5 kg by 7 kg is how much? Okay. See, this normal reaction force is responsible for the acceleration of 5 kg. Clear? So what about this normal reaction is mass into acceleration. Clear? Mass into acceleration, mass of the body is 5 into acceleration of the system. Clear? Listen, this system of 7 plus 5 kilogram, that is 12 kilogram block together accelerating with A. Okay, so what is that acceleration is force by mass. Force divided by mass, force is 6 Newton and mass is totally 12 kilogram. 6 by 12 is 1 by 2. That is 5 by 2, it is 2.5 Newton. 2.5 Newton is the normal reaction acting on 5 kg by 7 kg. Okay, so that is 2.5 is the answer. And remember, the same normal reaction will be there back on 7 kg. 2.5 will be back. And 6 Newton forward, 2.5 back. Then what will be the remaining? 6 forward, 2.5 back. That will be 3.5. 3.5 Newton is acting on 7 kg. Okay. Then 3.5 by 7, that is the acceleration 2 we are getting. Acceleration. So how much is the normal reaction on 7 kg by 5 kg? If that is asked, then also you calculate what about the normal reaction on 5 kg by 7 kg. We calculate it and we answer it as 2.5. So 2.5 here in this direction, 2.5 here in this direction. And remember, this force is on 5 kg and this green force is on 7 kg. One is action and the other one is reaction. Okay. Yes. Moving to the next concept is friction. We already discussed a certain point of static friction. The maximum value of static friction, Fs max, is equal to mu s into normal reaction. Okay, this is the maximum static friction. And the kinetic friction will be there during the motion of the body. That is mu k into normal reaction, mu k into normal reaction. Okay, for example, suppose this is a horizontal surface in which a block is placed. We are applying 10 Newton force, but the body is at rest, for example. The body is at rest. Suppose this is a 10 kilogram body, 10 kilogram body, and let the coefficient of friction here is 0.2. 10 kilogram body, and the coefficient of friction is 0.2. My question is, what is the frictional force acting on the block? Right? Okay. Suppose we are calculating this Fs max, frictional force Fs max here is equal to mu s into normal reaction. Mu s is equal to 0.2 into normal reaction is the weight of the body, that is 10 g 100. It is equal to 20 Newton. Now, is this 20 Newton is the frictional force right now on the body? No. The frictional force right now on the body is cancelling this applied force 10 Newton. So the frictional force right now it is just only 10 Newton. Then what about this 20 Newton is the maximum possible friction. Suppose we increase this 10 to 15, friction will be 15. We increase 18, friction is 18. We increase to 20, friction is 20. We increase to 25, friction is not 20. Friction is mu k into n, because we are exceeded the limit of static friction and we are applying 25 Newton means the block will slide. Okay. As of now it is at rest, means this 10 Newton is balanced. Understood? Okay. Now what is the frictional force is? 10 Newton only. I think you understood that. Suppose this is the another case in which here is the block of a 10 kilogram block. Okay. Let this mu s value is equal to 0.15 and let this mu k value is equal to 0.1 for example, and the applied force F. Okay, my question is find the acceleration. Find acceleration in first case if F is equal to 10 Newton. Second case if F is equal to 20 Newton. In these two cases find the acceleration. Okay, first we calculate mu s value is given 0.15. Then what is the Fs max? Maximum static friction. Maximum static friction is mu s into n. Mu s is 0.15. Normal reaction is 10g. 10g is 100. So this is 15 Newton. Okay, 15 Newton is the maximum static friction. Okay, in the first case we are applying 10 Newton. When we apply 10 Newton, what about this acceleration? When we are applying 10 Newton, it will be cancelled by 10 Newton because maximum 15 Newton is available as friction. So if we apply 10 Newton, it is cancelled, and in this particular case, what will be acceleration will be 0. Acceleration will be 0. Now, what about this 20 Newton is greater than this Fs max? Then the body will slide. Then what about in this particular case, acceleration is net force by mass. Net force by mass. What is the net force? Is in the forward direction we are applying 20. In the forward direction we are applying 20. And in the backward direction there will be Fk. You understood? And what is the equation of Fk? Fk is equal to mu k into n. Fk is equal to mu k into n. What is mu k value is 0.1 and normal reaction is 100. So this is 10 Newton. Okay. So if the body is sliding, now the friction is reduced to 10 Newton. Friction is now reduced to 10 Newton. You understood? Why this is minus 10? We are applying 20 Newton forward and the friction is 10 Newton backward. So what is the net force is 20 minus 10 divided by mass. Divided by mass is 10. Then 20 minus 10, 10 by 10. What is the acceleration right now is 1 meter per second square. 1 meter per second square is the acceleration right now. I think you understood the concept of static friction and kinetic friction well. Okay, that about the friction. This is the direct. Okay. Now, what about this question? A block of mass √3 kilogram resting on a horizontal surface. Yes, it is resting. Resting means its velocity is 0. Okay, its velocity right now is 0. Okay, then this F is acting at an angle of 60 degree here. Clear? Like this is the action of F. Then this angle is 60 degree. If this is 60, this is also 60. So this is 60 degree angle. So this is F cos 60. F cos 60. F cos 60. Cos 60 is 1 by 2. So this is F by 2 in this direction. And what about in this direction is F sin 60. F sin 60. That is √3 by 2. √3 by 2 times of F is acting downward. Okay. Due to this force, F by 2 is acting forward and √3 F by 2 is acting downward. This is the situation. And the mass of the body is √3 kilogram. Okay. Now, if coefficient of friction between the block be 1 by 2 √3. Coefficient of friction is 1 divided by 2 √3. Okay. What can be the maximum value of F so that the block does not start moving? Yes. What can be the maximum value of F so that the block does not moving? Means this F by 2 is cancelled by Fs max. Okay. That is this F by 2 cancelled by Fs max. Fs max is mu into normal reaction. Okay. Now we need to check this normal reaction also. What about the normal reaction here? Listen this situation. What are the downward force? The downward force, one is √3 into G. Okay. And the other is this √3 by 2F. These are the total downward force. This total downward force is balanced by the normal reaction. I think you understood this concept. The weight of the body is √3 into G. And there is this component of force is √3F by 2. Sum of these two forces is balanced by the normal reaction. So N is this much value, that is √3 into 10 plus √3 by 2 into F. Okay. Now what about this mu value? Mu value is what is this? Mu value 1 by 2 √3. 1 by 2 √3. Okay. 1 by. So this F by 2 is equal to, moving to the next page. F by 2 is equal to 1 by 2 √3 into 10 root 3 plus 10 root 3 plus root 3 by 2 into f. Okay, this 2 cancelled. So this f is equal to root 3, 1 by root 3 to the bracket is 10 plus f by 2. F by 2. So f minus f by 2 is equal to 10. Okay, f by 2 is equal to 10. That is f is equal to 20 Newton. Okay, so the maximum force can be applied is 20 Newton. It is equal to 20 Newton such that the block is not moving. So if you are applying this force greater than 20, the block starts moving. That's the situation. I think you understood it. Okay, yes. Come on. Now centripetal force. The centripetal force is the force necessary for keeping the circular motion. Centripetal force. And the equation of centripetal force we are already very familiar with. M mass is moving with a speed v through a radius r. Then what is the centripetal force formula? Fc is equal to mv square by r. Okay. It is also equal to mr omega square. Mr omega square, it's also equal to mv into omega. Okay. What we have used is v is equal to r omega. V is equal to r omega, then v square is r square omega square. R square and r, 1r is cut, then mr omega square. And mv omega also will be obtained. Okay. In different situations, this centripetal force is provided by different forces. For example, if this is a string, then what is the centripetal force provided by the tension acting on the string? And usually in this chapter, the question coming from the motion of vehicle along a curved road. Motion of vehicle along a curved road. In the case of motion of vehicle along a curved road, this vehicle on a curved road. Suppose this is a horizontal curve. It is not banked. In this case, the vehicle is moving. Okay. Then let this be the radius of the curve. Okay. Then the centripetal force is provided by the frictional force. Okay. So this centripetal force mv square by r is there. Okay. This centripetal force provided by the frictional force. Okay. But friction having a limit. Clear? Friction is having a limit. And the friction maximum value is Fs max. Okay. So this mv square by r should be less than or equal to Fs max. This is the situation of safe journey. This mv square by r, that is a necessary centripetal force. Okay. That should not be greater than Fs max. If this value exceeding the Fs max, then definitely the vehicle will slide. Okay. So this mv square by r should be less than or at least equal to Fs max. That is the condition for safe journey. Okay. Then when we equate this to Fs max, then this v is the maximum possible speed. Okay. mv max square by r is equal to Fs max. Okay. And what about the Fs max is mu s into normal reaction, that is mg. Okay. cut. So we have this v max square is equal to mu s rg. Mu s into rg. V max square is mu s into rg. So what is the maximum safe speed along a level curved road is root of mu s rg. Root of mu s rg. This is the situation along a level curved road. Clear? I think it's very clear. And if it is banked, then this Vmax is increased. Okay. If it is banked, then this Vmax, this Vmax, the numerator will be increased than this mu s rg, and the denominator will be decreased than 1. And hence Vmax is increased in the case of banking. We studied that. Okay. Now, listen to this question. A motorcyclist of mass m is to negotiate a curve of radius r with a speed v. The minimum value of the coefficient of friction so that this negotiation may take place safely. Here actually they are asking the minimum value of friction. The friction should not be less than this particular minimum value. If it is less than this particular minimum value, then the vehicle will slide. Okay, that's the situation. Clear? Yes. So what's our equation of v is equal to root of mu s rg. This is our equation, root of mu s rg. Okay. The situation is just like this value, root of this mu s rg should be greater than this v. That is the actual condition of safe journey. What is the condition of safe journey? That is that this speed should be less or at least equal. this speed should not be greater than this mu s RG. You understood? If this is greater than this mu s RG, then there will be sliding will be there. Okay, yes. Then what about this v square is less than or equal to mu s RG? Okay, then what about this static friction coefficient mu greater than or equal to v square by RG? V square by RG. Okay, now if this value is equated to this one, means that is a minimum possible mu. Okay, this mu should be greater than this value or at least equal to this value. This mu never should be less than this value. So what's the minimum possible static frictional coefficient is equal to v square by RG. The minimum possible coefficient is equal to v square by RG, v square by RG, v square by RG. This is the answer, option B. Understood? Okay, very simple. Direct questions are coming, nothing to worry. Now our topic is work energy and power, a conceptual chapter. Okay, whatever concepts or topics we have listed here in all the chapters, you just focus only on those topics. No other topics you take. Okay, for example, in the laws of motion, we have not discussed the concept of conservation of linear momentum problem. Conservation of linear momentum problem is there, explosion of shell, bomb, etc. problems there, not discussed there. Means as of now you don't take those topics right now. If you studied some problems already, then it's a bonus, let it be there. Okay, and as of now you didn't study those topics of conservation of linear momentum, then nothing to worry. Nothing to worry, only very less chance of questions coming from that. Okay, I may say no questions will be coming from that. Okay, so whatever topics we are listing here from each chapter, you focus only on those topics, and if you master all these topics, means definitely you can score 20 plus questions in out of 45 questions of NEET Physics. Today we are discussing this 11th topics only. Okay. And the first, this is the concept work, then kinetic energy, potential energy, work energy theorem is there, conservation of mechanical energy important, gravitational potential energy concept, potential energy of a spring, then motion along a vertical circle, motion along a vertical circle is there, then the concept of power is there, then collision questions are there. Okay, now first one is the work done. So work done by a force, okay. Work done by a force is integral of vector F dot vector dr is the general formula of work done by a force, okay. If force is constant, then this is F dot S or F dot displacement. If this is work done by a constant force, okay. If F is constant, taken outside, okay, then F dot S is the work done by a constant force. If force is not constant, then we are using this formula, no problem. Okay, this is the basic equation of work done, and we studied the concept of dot product, you can easily solve. Okay, then what about the kinetic energy? Is the energy due to motion of the body is very direct, half mv square. Half mv square is the equation of kinetic energy. Simply we are referring these topics, and kinetic energy and linear momentum is somewhat important. You know what this linear momentum, P is equal to mass into velocity. So what about P square is m square v square. What about P square by twice of the mass of the body is half mv square, we get it is half mv square. That is the kinetic energy of a moving body is P square by twice of mass. Okay, for a particular body, kinetic energy proportional to P square, okay, or P square is 2mk, P square is 2mk, or P is equal to root of 2mk. Okay, kinetic energy and linear momentum are related. Okay, if the question is about two different bodies, then you have to consider the mass also there. Okay, for a particular body, mass is constant, then its kinetic energy proportional to P square. Okay, now what about this question? If the kinetic energy of a body is increased 2 times, its momentum will be, what is that? We know the momentum is root of 2mk. Where in the question kinetic energy increased by 2 times. So k becomes root 2, means k becomes twice of k. Then the linear momentum root 2 times, it increases root 2 times. K is twice. Then linear momentum increased root 2 times direct. Okay, yes. Suppose the question is about Linear momentum is increased by 100%. And what about the percentage increase in kinetic energy? This type of questions. We have K is P square by 2m. What the idea of P increased by? Listen. The wordings should be very carefully listened. P is increased by 100%. Then one more P is added to P. Then the new P is twice of P. Twice of P. And K proportional P square. Twice of P all square is 4P square. Means kinetic energy becomes 4 times. Kinetic energy becomes 4 times. Okay. Means K becomes 4K. K becomes 4K means what's the additional K is 3K. K becomes 4K. So what is the additional K is 3K. 3K is, what is the change is 300%. The change is 300%. I think it's very clear. Is that clear? Okay. Now, potential energy. What's the concept of potential energy? Whenever there is the involvement of conservative force, there is potential energy. Okay. If conservative force is doing work, then work done by conservative force is negative of change of potential energy. This is your connection for potential energy. Fixed, always true. Okay. What is the work done by conservative force is minus delta U. Minus delta U. Okay. If conservative force is doing work on a system, then its potential energy decreases. I am allowing the conservative force doing work on the marker. I am releasing this. Now the gravitational force, which is the conservative force, doing work on the marker. And what happening to its potential energy? It is decreasing. Okay. If conservative force doing positive work, potential energy decreasing. And in this particular case of upward motion, what is the conservative force doing work is negative. Then the potential energy is increasing. Okay. I hope you very clear with this concept of potential energy change. Okay. Change in potential energy is the negative of work done by the conservative force. Potential energy is done. Okay. What about the gravitational potential energy? Consider this ground. Consider this a height point H. Okay. Now, the body is released from, M mass is released from this body. During its motion from A to B, A to the ground, what is the work done by the conservative force is minus delta U. Minus delta U is minus of final potential energy minus initial potential. That is initial minus final. Okay. What is the work done by conservative force is there mgh. Mg is the force and h is the displacement. Okay. So this mgh is the change of potential energy of these 2 points. That's it. That's it. Okay. Remember this g should be constant. Okay. That's why only this mg constant and we are taking work done by a constant force, that force into displacement. Okay. Okay. So this initial potential energy minus final potential energy is the work done by conservative force. Clear? Work done by conservative force. Suppose this is released from a huge height and is reaching the surface of the earth. Throughout this, g is not constant. So the work done by conservative force is not equal to mgh in that case. Then what to do is integration of f dot dr. That's the work done by conservative. Okay. Okay. If you know the formula of potential energy, then you can easily solve the change of potential energy and in the negative. That is the work done by conservative force. For example, this is the earth. And this point is at a height of 2r and this is r radius. Suppose the an object is released from A and it is reaching the surface of the earth, that is the ground. How much is the work done by conservative force? How much is the work done by conservative force? The answer is minus delta U. That is initial potential energy minus final potential energy. What is the initial potential of this surface? That we study in gravitation, minus J m1 m2 divided by distance from the center, this r plus 2r, this is 3r, minus g m1 m2 divided by distance from the center is r. Okay, what about this answer? That is the answer of work done by the conservative force here, work done by gravity here, true. And this equation we already derived, and this is discussed in gravitation. Okay, and this is the concept, and concept holding is highly beautiful. We can solve the questions. Okay, the decrease in the potential energy of a ball of mass 20 kg which falls from a height 50 centimeters. What is the decrease in potential energy? Is the work done by conservative force, and that is mgh. That is mgh in this particular case of 50 centimeter. 50 centimeters, very, very small height. And g is constant there. And mass of the body is 20 kg. And g is taken 10. Here this answer 98, etc. So g is taken as 9.8. Okay. Otherwise, if I take 10, then the answer will be very nearer to, okay, we can check 20 into 10, and what about h is 50 centimeter. 50 centimeter is half meter. 50 centimeter is half meter. 1 by 2. Okay, this is 2 into 5, that is 2 into 20, okay, 2 into 5, 10, 10 into 10, 100. Okay, 100 joule. Where is the answer? 100 joule. This is the answer, 100 joule, 98 joule. Okay, we understood why it is not 100, because this exact g is 9.8 approximate, or the average data of g is 9.8, and for simplicity we are taking it as 10. Okay, you understood? Decrease in potential energy is the work done by conservative force, and it is mgh here because the force is constant. Okay, yes. Moving to this question, means the next. Potential energy of a spring. Consider one end of a spring is attached and the other end is fixed to a block. If the string is not compressed, neither stretched, the potential energy is 0. Suppose the block is stretched, displaced to some x. Okay, there is potential energy stored. And the potential energy we derive it as, what is the potential energy? Again, our concept is simple. Work done by conservative force is negative of potential energy. That is initial potential energy minus final potential energy. And initial potential in this context we are considering it as 0, neither stretched nor compressed is 0. And minus final potential energy, that I am taking as F. What is the work done by conservative force? The conservative force here, it is Kx. Listen, it is Kx. In this direction it is Kx. And the displacement is from 0 to x. Displacement is from 0 to x. So what is this work done by this conservative force? Conservative force Kx is a variable force. So work done is integral from 0 to x of Kx dot dx. Kx is in this direction and displacement is in that direction. You understood? So Kx dx into cos 180. Kx in this direction, dx in that direction. So these two are in the opposite direction. Ks dx cos 180. Okay, this minus cancelled. Okay, then what this final u is equal to? This final u is equal to 0 to x k, kx dx. K is taken out. And what is the integration of x dx is x square by 2. X square by 2. This is the potential energy of the spring. Okay, okay. From the equilibrium position, we are stretching the spring to x. What is the potential energy? Is half kx square. Potential energy is the half kx square. Half kx square. Potential energy is the half kx square. Okay. Now listen. The potential energy of a certain spring when stretched through a distance s is 10 joule. Okay. When stretched through a certain distance s, the potential energy is 10 joule. Okay. Then what that? Half into k into s square. That is equal to 10. That's it. The amount of work that must be done on this spring to stretch it through an additional distance s. Already s is the stretching, and an additional s means from s to 2s. You understood? From s to 2s. This is the spring. This is the equilibrium point. For example, x is 0. And here was the block s. And now again it is another s. And here is the block now. So 0 to S, 0 to 2S. Okay. So what's the additional work from S to 2S? This value is S and this value is also S. This is the additional S. Okay. So what this stretching is from S to 2S. Okay. So how much is the work done by us from S to 2S is we are applying Kx force to counter this restoring force from S to 2S or from x1 to x2. Suppose this from x1 to x2, Kx dx. What this is? Half into K into x2 square minus x1 square it comes. Okay. This is the work done to stretch a spring from x1 to x2. From x1 to x2. Study this formula W. Half into K into x2 square minus x1 square. This is the work done to stretch a spring from x1 to x2. Half K into x2 square minus x1 square. Okay. Here x2 is 2S. x1 is S. Clear? So what this is? Half into K into 2S square is 4S square and S square there. Okay. x2 is 2S. 0 to 2S and 0 to S. So this is x1 and this is x2. Okay. 4S square minus S square is 3S square. This is 3 into half K S square. 3 into half K S square. What is half K S square is 10. It is 10. So 3 into 10. 3 into 10, 30. Where is that? 30. So option A. You understood? It is option A. Clear? Clear. Okay. Yes. Then work energy theorem. What is the work energy theorem? Very well known, famous work energy theorems that work energy theorem is that work done by all forces on a body. Work done by all forces on a body is equal to change in kinetic energy of the body. Work energy theorem. Okay. There will be a situation, there will be a question in which some forces will be there doing work on the body. Gravity is there, friction is there, tension is there, etc. Okay. And work done by all these forces on the body will change the kinetic energy. Work done by all forces on the body will be delta K. This is the statement of work energy theorem. I hope you understood. And we may take an example, then you will understand this very clearly. What is the example? Just listen. A car weighing 1400 kg is moving at a speed of 54 km per hour. 54 km per hour means 15 meter per second. 54 into 5 by 18 meter per second. Kilometer per hour, and this one is 15 meter per second. Okay. Up a hill, when the motor stops, it is moving up a hill and the motor stops or the engine is stopped. If it is just able to reach the destination which is at a height of 10 meter above the point, inclined plane, from this point suppose the engine is stopped and it is just able to reach the destination. This destination is at a height of 10 meter. At a height, this height is 10 meter is given. Okay. Then the work done against the friction is, what is the work done against the friction? See, this is the vehicle moving in this direction. So what are the agents doing work on this? One is the gravity doing work and the other is the friction doing work. These two works are the total work done and that is equal to delta K. Work energy theorem. Okay. And remember what this work done by gravity is minus delta U. Minus delta U. Why? Why? Minus delta U is the work done by conservative force. Gravity is conservative force. Then work done by friction is delta K. Okay. Now what about the work done by friction is delta K plus delta U. Work done by friction is equal to delta K plus delta U. Okay. What is delta K is final kinetic energy minus initial kinetic energy. Okay. Delta U is the change of potential energy. Listen, what about this change of potential energy? Potential energy of this level and this level. Change is final minus initial. Final minus initial is mgh. Final is higher potential energy. Initial is lower, and that difference is mgh. The difference is mgh. This is the work done by friction. Minus half into mass of the vehicle is 1400 kg and the speed is 15 meter per second. Speed is 15 meter per second square plus 1400 into g is 10 and h is 10. H is 10. Okay. Minus 700 into 225 plus 140000. Okay. And the options are in kilojoule. Options are in kilojoule, so divide this by 100. 1000. 1000 we are dividing means minus 7 into 2.25. Okay. Then here 1, 2, 3. Then 140. Okay. This much kilojoule. Okay. Is that okay? 22.5. Here will be the decimal. Here will be the decimal. 22.5. Okay. Listen. 7 into 20 is 140. So minus 7 into 20 is minus 140 and this 140 will be cancelled. And the remaining is minus 7 into 2.5. Minus 7 into 2.5 is 17.5. Minus 17.5. Minus 17.5. So this is the answer. Negative of the work done by the friction is asked. How much is the amount of work done by the friction? They are asking negative of the work done by the friction. The work done by the friction we obtained as minus 17.5 kilojoule. Negative of this one is positive. And that is asked here. That is our option is option C. Our option is option C. So very simply done by the application of work energy theorem. Okay. What that work done by all forces is equal to change in kinetic energy. Okay. Good. Very good. Moving to the next one, conservation of mechanical energy. Okay. We have the concept of work energy theorem that work done by all forces is delta K. Suppose if all forces are conservative. Suppose if all forces are conservative. If all forces are conservative, then what this one will be work done by conservative force is delta K. And we have this is minus delta U and this is delta K, which means delta K plus delta U is 0, which means delta of K plus U is 0. That is mechanical energy change. K plus U is mechanical energy. Kinetic energy plus potential energy is mechanical energy. Mechanical energy change is 0, which means mechanical energy remains constant. Okay. Now what is the statement? If the forces doing work on the body is only conservative, if all the forces doing work on the body are conservative, then the mechanical energy will be constant. That is the situation of conservation of mechanical energy. Solving this question, that a mass of 0.5 kilogram, this is 0.5 kilogram, 0.5 kilogram mass, with moving with a speed of 1.5 meter per second, 1.5 meter per second on a horizontal smooth surface, so there is no friction involved. No friction involved means the force here, spring force, that is conservative force. Okay. Collides with a nearly weightless spring of force constant K is 50 Newton per meter. Okay. What is the maximum compression here? See, while it collides and it is starting to compress, its kinetic energy reduces and becomes 0. Okay. So that kinetic energy change and potential energy change are equal and opposite here, since the force involved is only the spring force, that is conservative force. Okay. So what is the delta K value is minus delta U. Okay. Or what is the delta U value is minus delta K. Whatever it may be, no problem. Okay. What is the delta K is final kinetic energy minus initial kinetic energy. Okay. What is minus delta U is initial potential energy minus final potential energy. what is the potential energy of a spring is half kx square. Okay, minus minus cut, clear. What about this x square is equal half cut. Okay, x square is equal to m by k into v square. M by k into v square. Okay, so what this is equal to, mass of the block is 0.5 and spring constant is 50. Okay, and this v square is 1.5 square. 1.5 square. So what about this x is root of this into 1.5. This is actually 5 by 500, 1 by 100. Root of 1 by 100 is 10. So it is 1.5 divided by 10. That is 0.15 is the x value. The x value is 0.15 meter. 0.15 meter, it is option 2. Okay. Yes. Then motion along a vertical circle. Listen. Consider a vertical circle. Okay. Suppose the body moving along this vertical circle, that the radius of this is r. Radius of this circle is r. Okay. Then at the bottom, velocity at the bottom should be greater than root of 5 gr. Listen this. Should be greater than root of 5 gr in order to complete this vertical circular motion. Okay. A minimum velocity at the bottom should be root of 5 gr. If this is the velocity at the bottom, root of 5 gr, it's just completing the vertical circle and it is moving like this, just completing a vertical circle. So a minimum of root 5 gr should be here. Okay. Then if root 5 gr is the velocity here, then here it is root 3 gr and here it is root gr. Listen. If this condition of just completing vertical circle, vertical circular motion, then velocity at the bottom is equal to root of 5 gr and velocity at the top is equal to root of gr, and velocity at the middle, velocity at the horizontal portion, that is the middle, I am mentioning root of 3 gr, root of 3 gr. Okay, these are the velocity. Okay, and one more point is the difference in tension at the top and the bottom is always 6 mg. The tension at the bottom minus tension at the top is equal to 6 mg. Okay, and this condition of just completing vertical circular motion means tension at the top is 0. When the body reaches the top, the string becomes tension free. That is a condition of just completing. Then what will be the tension at the bottom? Here this value 0 means tension at the bottom will be 6 mg. Okay, if it is moving with a greater velocity like this, then here the tension is not 0. If here the tension is 2 mg, then what will be the tension here will be 8 mg, because the difference always is 6 mg. Okay, suppose here I am asking you what is the velocity, of the body at the bottom. Velocity of the body at the bottom, this is asked you, such that the string experiences a tension when the body reaches the top. The tension experienced at A is mg. If the tension experienced at A is mg, I'm asking you what is the velocity at the bottom. I'm asking you. Then in this question the answer is here. I told you the tension here is tension at the top plus 6 mg. Okay. The tension at the bottom is 6 mg plus tension at the top. Tension at the bottom is 6 mg plus tension at the top. Okay. Now here what the tension is 6 mg plus at the top is mg, so it is 7 mg. And downward it is mg. Okay. So what this difference is 6 mg. This 6 mg is acting as the centripetal force and it is mv square by r. Okay, so this m cut. Okay, so what about this v square is 6rg. What about this v square is 6rg. Then what about the speed is root of 6rg. Root of 6rg is the speed at the bottom. I think you understood. Root of 6rg is the speed at the bottom. Okay, then what will be the speed is root of 4rg. Root 2rg is subtract. Root of 4rg. What will be the speed here is root of 2rg. Root of 2rg. This is the connection between them. Listen that. Okay. Okay. Then that vertical circle is finished. Now what about this? A mass is attached to the end of a rod of length L. The mass goes around a vertical circular path. So vertical circular path, and a mass is attached at the end of a rod, and the length of the rod is L. Okay. With the other end hinged at the center. This is hinged at the center. Okay. What should be the minimum velocity of mass at the bottom of the circle so that the mass complete the circle? Direct question. To complete the circle, what should be the minimum velocity? Here is root of 5gr. Okay. By hurting this, root of 5gr is the minimum velocity at the bottom to complete the circular motion. Then what will be here the velocity? Root 2gr is subtracted. So here root 3gr. And what is here? Again root 2gr is subtracted. So it is root rg here. It is root rg here. Okay. What about here is? What is the velocity here? Same velocity here. Root 3rg. Okay. Yes. Now the concept of power, you know, power is the rate of doing work dw by dt. Okay. This is the instantaneous power. Okay. This is instantaneous power, and it is also written as F dot velocity. F dot velocity. The rate of doing work, instantaneous power, and also F dot velocity. Okay. Suppose two bodies are doing same work in different time. Same work in different time. The one which is using less time is having greater power. Okay. We are doing a work in a less time means our power is great. Okay. That concept is very clear there. Okay. And this is the instantaneous power formula. Okay. Now, suppose a simple question is here. A man does a given amount of work in 10 seconds. Another man does the same amount of work in 20 seconds. So the work done is same. Okay. So the average power is work done by time, we say. Then what this average power is inversely proportional to time for the two men, because the work done is same. Okay. Then the ratio of the output power of first man to second man. Power of first man, power of first to second. Power of first to second is equal to inverse ratio of time. Time taken by second man divided by time taken by first man. Time taken by second man is 20 and first man 10. So the answer is 2:1. Okay. 2 by 1. 2 by 1 is the answer, option C. Very straight. Clear? Okay. That's a case of power. And what about the collision? Collision, generally we are having one-dimensional collision and two-dimensional collision. One-dimensional collision and two-dimensional collision. Okay. And also we are having elastic collision. We are having this elastic collision and non-elastic collision. Non-elastic collision. We are having elastic collision and non-elastic collision. Okay. See, there is a term named coefficient of restitution. Coefficient of restitution is E is equal to the relative velocity of separation divided by relative velocity of approach. Okay. Suppose these two bodies are moving and colliding. Initial velocity u1 and u2. Okay. Final velocity v1 and v2. Final velocity v1 and v2. Okay. Then what is the coefficient of restitution is relative velocity of separation, that is v2 minus v1, divided by relative velocity of approach, that is u1 minus u2. This is the coefficient of restitution. Okay. Now E is equal to 1 means elastic collision. E is equal to 1 means elastic collision. Elastic collision. Then E is equal to 0 means perfectly inelastic collision. Okay. Perfectly inelastic collision. Perfectly inelastic collision. Okay. And remember, in all collisions, linear momentum is conserved. Conservation of linear momentum is applied in all collisions, whether it is elastic or inelastic. Okay. And if it is elastic collision, then there is one more equation we can write, that initial kinetic energy and final kinetic energy are equal. Initial kinetic energy and final kinetic, initial total kinetic energy and final total kinetic energy are equal. That is the elastic collision. And in the case of inelastic collision, there will be kinetic energy loss will be there in some other format. Okay. that is inelastic collision. Okay, so this is the basic of collision there. Okay, and there the equation of final velocity v1 and final velocity v2 can be derived. Final velocity v1 and final velocity v2 can be derived by these concepts of conservation of linear momentum and this coefficient of restitution value v2 minus v1 divided by u1 minus u2. We can solve a final velocity formula there. Okay. Now what about this question? Two putty balls of equal mass moving with equal velocity in mutually perpendicular direction. Stick together. Sticking together means perfectly inelastic collision. See, in the case of sticking together or in the case of perfectly inelastic collision, you understand the bodies stick together. Stick together. Stick together is perfectly inelastic collision. One body and another colliding, and after collision they are moving together. That is the perfectly inelastic collision, that is sticking together. Okay. Now what about this question? Listen me. Two putty balls moving with equal velocity in mutually perpendicular direction. Okay. Consider this one in this direction and another one in this direction. This is moving in this direction, this is in this direction with equal speed. Okay. Stick together after the collision. If the balls were initially moving with a velocity of 45 into root 2. Here. These are sticking together, listen me. These are sticking together and the mass, let this mass is m, this is also m, then this mass is 2m. Okay. Now, what the point is, conservation of linear momentum is applied here. Okay. Here, in this direction, initially along x direction, there is momentum mv. So, after collision also there should be momentum mv along x direction. Momentum mv should be along x direction. Okay. And in the y direction, there is initial momentum along y direction is mv. So, after collision also along y direction, momentum should be mv there. Okay. So, the x component of final momentum is mv, the y component of final momentum is mv, means the final momentum is in this direction. The final momentum is in this direction. Okay. Okay. Its x component is mv, its y component is also mv. Then what is this one will be root 2 times of mv. Root 2 times of mv. This is the final momentum. Final momentum is this one, because this is mv, this is mv. How we understood this is mv? Because initially there was momentum along x direction as mv, and initially there was momentum along y direction also mv. So the momentum should be conserved. So this is mv means the resultant is root 2 times of mv, and that is 2m into final speed v dash. Okay, the velocity of the combined mass is asked. Okay, root 2 times of mv is equal to 2m. 2m is the combined mass, and let this velocity be v dash. And mass is 2m and the velocity v dash. Then what is the final momentum is 2m into v dash. 2m into v dash. mm is cut. Okay. So what about this? V dash is root 2 v divided by 2. Okay. Root 2 into what is v is 45 root 2 divided by 2. Root 2 by 2 is cut, and the answer is 45 meter per second. Okay. 45 meter per second, the answer is option B. It's very simple. And here this is the collision along 2 dimension. Okay. And the conservation of linear momentum is applied here. Good. Okay. Now this chapter of system of particles and rotational motion. Come on. System of particles and rotational motion. The concept are center of mass, torque and angular momentum, conservation of angular momentum, moment of inertia, rotation of rigid body. Okay. And also the mechanical equilibrium is also another important concept of mechanical equilibrium. Mechanical equilibrium. Okay. And remember, there is no rolling motion. No rolling motion is discussed here. So no rolling motion as of now, you don't touch that. Only study these much topics. And it's a very simple chapter right now, because only these topics are here. Okay. Moving to this topic of center of mass. Consider this M1, M2. M1, M2. The basic equation of position of center of mass, we know xcm is m1x1 plus m2x2 divided by m1 plus m2. Okay. Suppose this separation is r. Okay. Then where is the center of mass located? Let this be r1 from m1 and r2 from m2. Okay. Then the position of center of mass from m1 is the other mass m2 into separation r divided by sum of masses. This concept clearly understand. So what is the position of center of mass from m2? That is r2 is equal to the other mass m1 into separation divided by sum of masses. For example, this mass 2 kilogram and this mass 3 kilogram. Okay, let this distance be 6 meter. Okay, where is the center of mass from 2 kg? Okay, from 2 kg. Where is the center of mass from 2 kg? The other mass into separation divided by sum of masses. From 2 kg, what is the distance of center of mass? The other mass into separation divided by sum of masses. 6 by 5 is 1.2. 1.2 into 3 is 3.6. 3.6 meter. I hope you understood that. Okay. And if there are more masses, we can easily use that xcm is m1 x1 plus m2 x2 plus etc. divided by total mass. Ycm zcm also can be utilized. Okay. Now what about this question? After solving this question, we move to the another one. The center of mass of 3 particles of masses 1 kg. Listen, m1 is 1 kg, 2 is 2 kg, m3 is 3 kg. Okay. Center of mass of these 3 particles is 2, 2, 2. 2, 2, 2. Okay. xcm 2, that is ycm and that is zcm. Okay. Now, the position of the fourth mass 4 kg, fourth mass is 4 kilogram, to be placed in the system as the new center of mass is at 0, 0, 0. The new center of mass is at 0, 0, 0. Okay. So where should be the fourth mass placed such that the new center of mass is at origin? That's the question. Yes. So I am using this equation of xcm of 3 particles m1 x1 plus m2 x2 plus m3 x3 divided by sum of masses. Initially this xcm is given 2, m1 is 1 into x1, m2 is 2 into x2, m3 is 3 into x3, sum of mass 1 plus 2 plus 3, that is 6. So we obtained x1 plus 2x2 plus 3x3 is 12. x1 plus 2x2 plus 3x3 is equal to 12. Okay. Similarly, y1 plus 2y2 plus 3y3 is also 12, because this is ycm is also 2, zcm is also 2. So similarly, y1 plus 2y2 plus 3y3, this will be also 12, and z1 plus 2z2 plus 3z3 is also 12. Okay, why this formula? Now we are placing the fourth mass and getting the position of center of mass at origin, that is x coordinate is 0. Okay, so after placing the fourth mass, what's our xcm is? xcm m1x1 plus m2x2 plus m3x3 plus m4x4 divided by total mass, and this is given 0, the new position is 0. And what about this m1x1 plus m2x2 plus m3x3, that was 12. Yes, m1x1 plus m2x2 plus m3x3, that is 12. Okay. plus m4 is 4 into x4. We don't know what is x4 and we are solving that. The total mass 10. 0. 4x4 is 12 minus 12, isn't it? Yes. x4 is minus 3 meter. Yes. Similarly, y4 also will be minus 3 because same number of this one 12. 4. What this 4y4. This is 12 and 4y4. Again 0. Then y4 is also 0. Means minus 3. And z4 also will be minus 3 meter. All these coordinates are minus 3, minus 3, minus 3. So we have to place the fourth mass at minus 3, minus 3, minus 3. Then the center of mass of the whole system will be changed to origin. Okay. I hope you understood and this is the answer. Okay. Now what about the moment of inertia? Consider here is a mass m. At a radius r it is rotating, then what is the basic formula of moment of inertia is mr square. Basic formula. Okay. And this is a point mass. If this is not point mass, then we are having this circular ring based on this axis. Moment of inertia is mr square. Then this circular disc based on its own axis. Moment of inertia is mr square by 2. Okay, and this hollow cylinder based on its own axis mr square. Then this solid cylinder based on its own axis mr square by 2. Okay, then this uniform rod based on this central axis moment of inertia ml square by 12. Okay. Then this solid sphere based on its diameter moment of inertia 2 by 5 mr square. Then this hollow sphere based on its diameter moment of inertia is 2 by 3 mr square. These are the moment of inertia of continuous mass distribution important formula. And if the axis is changed, we can use the theorems on moment of inertia. Isn't it? Okay. What is the moment of inertia of a solid sphere of density rho and radius r about its diameter? Solid sphere. About the diameter 2 by 5 mr square. 2 by 5 into mass is volume into density. Volume into density into r raised to 2. Okay. 2 into 4, 8 pi. Divided by 15. Then rho into r raised to 5. Rho into r raised to 5. Here is one option. Rho into r raised to 5, here is another option. So either this one or this one. And pi is 22 by 7. Pi is 22 by 7. Then rho into r raised to 5. Okay. 8 into 22 is 176. 176, 15 into 7 is 105. So this is our answer option C. Yes. The answer of this one is option C. Clear? Okay. Now this theorems on moment of inertia, perpendicular axis theorem and parallel axis theorem. This is a planar body in which we are having x, y, z planes, x, y, z coordinates, axes are there. Okay. What is the moment of inertia of the body based on z axis is the sum of moment of inertia based on x and y. This is perpendicular axis theorem. Isn't it? Perpendicular axis theorem, it is very simple. Very direct perpendicular axis theorem. And what about the parallel axis theorem? Suppose this is a body. Center of mass is there and let this be the axis passing through center of mass and moment of inertia of this body based on this axis ICM. And there is a parallel axis at a distance A. And what about its moment of inertia is ICM plus mass of the body into square of the distance. IC equal to ICM plus MA square. This is called a parallel axis theorem. And this is highly useful. Okay, because it can be applied on all types of bodies. But this can be applied only on planar bodies. This is a plate. Planar bodies only this one perpendicular axis theorem. This is on all bodies. This is highly useful. Okay. So just check this question. A solid sphere of radius r has moment of inertia about its geometrical axis. It's a solid sphere. Its moment of inertia is 2 by 5 mr square. Okay. If it is melted into a disk of radius r, this is melted into a disk so that its mass is not changed. And thickness t, this is melted into a disk of radius r and thickness t. This thickness is t and the radius is small r. Okay. If its moment of inertia about the tangential axis which is perpendicular to plane, the tangential axis which is perpendicular to the plane, this I, is same. Okay, it is same. Then what is the value of r? We use this I by parallax theorem. This is ICM of the disk is same mass of this one m, but radius is different, so mr square by 2. So what this I value is ICM plus mass into square of this distance, isn't it? Mr square by 2 is ICM plus mr square. It is 3 by 2 mr square. And this moment of inertia and this moment of inertia are equal 2 by 5 mr square. Is equal to 3 by 2 mr square. Mass cancelled. Okay. What about this? R square is 2 into 2, 4 divided by 3 into 5, 15 of capital R square. Okay. Isn't it? And what this R is equal to root of, that is 2 into root of 15 into capital R. Okay. 2 by root of 15 into capital R. This is option A. It's very direct. It's a direct question, but we are used to this parallax theorem. Parallax theorem is very clear. Moment of inertia based on this axis, the ICM value plus mr square. ICM value should be by heart. Mr square by 2 for the disk. Torque and angular momentum. What this concept of torque and angular momentum? Okay. You know, consider a object which is having a position vector r based on this point, and this is the interaction of force F. Then what is the torque acting on this body based on this point is r cross F. R cross F. Okay. Actually here this magnitude tau is r of sine theta. That is force into r sine theta. Here actually theta is this angle. Between this vector r and force, this is the angle theta. And we can understand when you extrapolate the direction of force, this is r sine theta. This perpendicularity is r sine theta. So what is the value of torque is your force into perpendicular distance from the axis to the direction of force. Okay. Force into, suppose this is a rod. Okay. You are applying force in this direction. In this direction you are applying force. What is the torque based on this point? So you are drawing a perpendicular distance from this point to the direction of force. This is that perpendicular distance. Okay. Now what is the torque is? Suppose this point is O and this point is M, then what is your torque based on this axis due to this particular force is F into OM. That's a basic idea. And to get to OM, some angle theta will be there and some length will be there here, etc. Will be there. Okay. Force into perpendicular. Suppose this is the rod and the weight of the rod is acting mg, and this rod is rotatable based on this end, suppose. Then what is the torque due to weight of the body about this end? About this end is mg into this length. Let this length is L by 2, total length by 2. So what the torque due to the weight based on this point is mgl by 2. This is torque based on A. And let this point is O. Then what is the torque based on O? torque based on O is here 0 because that mg is passing through O. That mg is passing through O means what is the perpendicular distance is 0. Then the torque is 0. So the torque due to a force changed according to the defining point. If we change the defining point here, what is the torque in this figure based on this point? 0, because the force is passing through that point. Okay, that's the idea of torque. And the concept of angular momentum is applied here, then we get the torque is the first derivative of angular momentum dl by dt. Okay, this is Newton's second law in rotation. dl by dt, torque is dl by dt. Okay, fine. Okay, now we may have another connection with the angular momentum and moment of inertia as L is equal to I omega. Keep this. L is equal to I omega. And also this torque is d by dt of L. L is I omega. And I into d omega by dt, that is alpha angular acceleration. Alpha is called what? Angular acceleration. Alpha is called angular acceleration, that is the derivative of omega. Okay. So tau is I omega, sorry, L is I omega and torque is I alpha. Here. Then what about this question? Come on. See, a uniform rod AB of length L and mass M is free to rotate about point A. It is rotatable about point A. Okay. The rod is released from rest in horizontal position. If it is released, then there will be action of weight and there will be torque there based on A. Then based on A, the torque is mg into L by 2. This is the torque. The moment of inertia of the rod about A is ml square by 3. I is given. What is the initial angular acceleration? Torque is replaced as I alpha. Torque is replaced as I alpha and it is mgl by 2. And I is given that ml square by 3 and it is mgl by 2. Cut, one of the L also cut. Okay, and there is alpha is there missed. Okay, mg L square by 3 into alpha. Okay, here alpha is here. Okay, okay. One of the L is cut and what your alpha is equal to 3 times of g divided by 2 times of L. Alpha is equal to 3 times of g divided by 12. 3g by 12. Where is that? 3g by 12. This is option D. 3g by 12 is that. It's very direct. Understood? Okay. Come on. What about this conservation of angular momentum? We have the torque is dl by dt. Okay. This is actually the external torque. Okay. If external torque acting on the system is 0, then dl is 0, which means dl is 0, which means L remains constant. Angular momentum is constant, that is I omega is constant. So two situation of rotation of a system in which there is no external torque involvement, then I1 omega 1 product will be equal to I2 omega 2 product. Two situation of rotation of a system in which there is no external torque involvement, then I1 omega 1 is equal to I2 omega 2. This is the conservation of angular momentum. Okay. Now rotation of a rigid body and rotation equation, we know. Already we studied something, this omega is d theta by dt. And it is 2 pi by t and 2 pi into nu, all this we already know. Okay. And in the case of omega constant motion, then we have the equation of delta theta is omega into t. This is uniform circular motion equation. This is the equation of UCM, uniform circular motion. It's just like S is equal to Vt. Okay. And if there is alpha constant, we have final omega is initial omega plus alpha t. Then final omega square is initial omega square plus twice of alpha into delta theta. and delta theta is equal to omega 0 t plus half into alpha t square, just like the comparison 2. Compare this equation with the uniform accelerated motion. Okay, there is here delta theta, there theta here x, sorry, there x, here it is theta. There it is velocity, here it is omega. There it is acceleration, here it is alpha. There it is linear momentum p, here it is angular momentum L. There is force, here is torque, etc. Comparison. You can use this formula. What about this question? A disc of mass 2 kg and radius mass of the disc is 2 kg. And radius is 0.2 meter. Okay. Rotating with angular velocity omega is equal to 30 rad per second. Okay. What is angular velocity if mass is 0.2, if mass of 0.25 kg is put on periphery of the disc? The disc was rotating like this. Okay. Then finally some mass is put on the periphery. Here. Okay. It is just put there means there is no external torque involvement there. Okay. Yes. Rotational equilibrium. Okay. Okay. Its question can be rotational equilibrium question can be done. Okay. Yes. Now this in this particular case, see, there is no external torque involvement there, which means I1 omega 1 value here and this I2 omega 2 value here will be same. Okay. Now omega 1 is given, and what this I1 is mr square by 2. Mr square by 2 and omega 1 is equal to, what about in this particular case, the total moment of inertia is mr square by 2 plus this small m into r square. This is the moment of inertia of that small m, because this small m is rotating based on this origin and the distance is capital R. So what is this moment of inertia is mr square into omega 2. Okay. Now putting the values, mass of the body is 2, then by 2 it is cancelled. Radius is 0.2, its square. And omega 1 value is equal to 30. This is the initial omega 1. Okay. Here this m by 2 is cut and 0.2 square plus small m is small m. How much mass is added there? How much mass? 0.25. That is 1 by 4 into radius is 0.2 square. Okay. Into omega 2. Into omega 2. Okay. Am I right here? Listen. M is 2. 2 by 2 is cut. Then here it is 0.2 whole square. Into omega 1 is 30. And then this mr square by 2 is again 0.2 square plus small m is 1 by 4 and radius is 0.2 and its square into omega 2. Okay, this is 0.04. 0.04 into 30. This is 0.04 plus 0.04 by 4 is 0.01 into omega 2. Okay, here it is equal to into omega 2. Okay, and this answer is 3 into 0.4, that is 1.2, and this one is 0.05, and this is your omega 2 value. Okay, then 1 2, then 1 2. Okay, 1200 by 5, and I think that is 24 rad per second is the answer. 24 rad per second is the answer of this question. Check that. Okay, it's very direct. Clear. Now what about this gravitation is there? Before that, see, mechanical equilibrium concept is there. We may discuss those concepts also. There mechanical equilibrium concept. Mechanical equilibrium. Okay, one example is, consider this scale. Okay. Suppose it is balanced at its midpoint. Okay. Now it is in equilibrium. It is not rotating and it is not translating, it is in equilibrium. Okay. Means weight of the body is balanced by this support. Okay. Suppose this one is a meter scale. Means this is 0 centimeter, this is 50 centimeter length. This is 100 centimeter mark. Okay. Suppose we are placing at 30 centimeter mark. 30 centimeter mark, we are placing a body of mass. 2 kg is placed here. 2 kg is placed here. Where should be another mass of 3 kg is placed? Where is another mass? Here. Let this be 3 kilogram. Where should be this 3 kilogram placed such that the rod is in equilibrium? The rod is in equilibrium. This question. See. Already this is at this midpoint is the fulcrum is. So you take the torque based on this point as 0 for this equilibrium. For this equilibrium, net torque is 0. Then torque based on O is 0. Means torque due to 2 kg is cancelled by torque due to 3 kg. Understand? Torque due to 2 kg is 2 kg weight into this distance. This distance is 20 centimeter. Listen, this is 30 means the remaining is 20. Okay. And this, what about this torque is 3 kilogram, that is 3g, 3 kilogram into g into this distance r. Okay. Listen. Okay. Then what about this g cut and this r is equal to 40 by 3. What about this r is equal to 40 divided by 3. 40 divided by 3 is 13.33. 13.33 centimeter. Remember, this distance is 13.33 centimeter. So what about this mark? This mark is from 0. 0 to this one is 50. 50 plus 13.33, that is 63.33 mark. So we have to place this 3 kilogram at 63.33. This distance is 13.33. So what about the mark is 50 plus 13.33, that is 63.33 centimeter. At that particular place we have to place this 3 kilogram. Okay, it's very clear. This is the concept of rotational equilibrium, and here is the translational equilibrium also satisfied. Okay, what is the condition of translational equilibrium is the total downward force is balanced by this fulcrum. So the net force is 0. Okay, to find this particular distance we are using the rotational equilibrium concept. Okay, this torque and this torque are balanced. Okay, and the torque is force into distance. Force into distance. Okay, I think it's clear. Okay. Now the chapter is gravitation. It's a very simple chapter. And the topics, universal law of gravitation. Okay. Acceleration due to gravity is variation at a height and at the depth. Gravitational potential energy, that formula minus Gm1m2 divided by r formula. Kepler's laws of planetary motion, the law of area, the law of period, and the law of orbit. Then motion of a satellite. Motion of a satellite is orbital velocity, its time period of the satellite, the energy of the satellite. Energy of the satellite is there. Okay. Geostationary satellites not involved. Polar satellites are also not involved. Only this much topics we need to understand. Okay. And what about this universal law of gravitation? There is the gravitational attractive force between any 2 point masses in the universe. Between any 2 point masses in the universe, there is gravitational attraction. It is independent of the medium. And there is a constant G coming. It is independent of the medium. Suppose this mass is placed in air or in water or in oil or in any other medium, the force remains same as long as the masses product and their separation is same. So this F is equal to Gm1m2 by r square. This is Newton's law of gravitation. Okay. The important point is independent of medium and its value and its dimensional formula. Okay. What is the dimension formula of G? Okay, it is usually coming in the question in our units and measurement. Okay, force into r square. What about force is ml t raised to minus 2 into r square is l square divided by product of mass is m square. So this is m raised to minus 1 l cube t raised to minus 2. Universal gravitational constant dimensional formula m raised to minus 1 into l cube into t raised to minus 2. Okay. Yes, this is the force. Okay. Now see acceleration due to gravity. Yes, acceleration due to gravity, consider this earth of mass m. Okay. Then on its surface value I am writing that g as gm divided by r square. Surface value we are writing the acceleration due to gravity as gm divided by r square. And at a height h from the surface, let this be capital R, and at this height the value of acceleration due to gravity is on the surface, then capital R by small r whole square, by heart this formula, at a height h. Okay, not 1 minus 2h by r, g into 1 minus 2h by r, one formula is there, but it is an approximate result, cannot be used in all situations. But this equation can be used in all situations. Remember, what about this small r is r plus h? Remember, this small r is r plus h. So at a height h, you study this formula, surface value, then r by r whole square. Okay. Now at a depth d, here this is the depth from the surface, let this depth is d, let this depth d, at a depth d, at this point, what about the acceleration due to gravity at a depth d is surface value into 1 minus d by r. This is always true. This is always true, not approximated result. Okay. At the center means what's the depth? At the center means the depth is capital R. At the center, what's the depth is from the surface, this is d. At the center is depth is capital R, r by r is 1, 1 minus 1 is 0, g into 0. So at the center, at the geometric center, acceleration due to gravity value is 0. Okay. Clear. And what about this on the surface value gm by r square, and there is variation in the equator and the pole. Okay. See, earth is actually a geoidal shape, we know, and this is the equator belt, and to the equator the radius is greater and the pole radius is less. Okay. So acceleration due to gravity on the equator, this r is greater. So acceleration due to gravity on the equator is less than the acceleration due to gravity on the pole. Okay. So on the surface this is gm by r square, but that value itself is varying since the radius is not same, because earth is not a perfect sphere, its shape is geoidal. Okay. And at the equator, greater radius compared to the polar radius. Since the radius is less at the pole, g value at the pole is greatest on the surface of the earth, and the average value of g is taken as 9.8 meter per second square. Okay. Yes. Now what about this? The acceleration of a body due to the attraction of the earth at a distance 2r from the surface of the earth is, this question is, this is the earth, radius is r, and at a height 2r, what is this acceleration due to gravity? gh is g into r by r whole square, very direct. G in the options, g there on the surface value, capital R by, what about this center distance from center to this point is 3r whole square, r cut 1 by 3 square is 1 by 9, g by 9. G by 9 is the answer, option A. Understood? So surface value is g, and at a height is g into r by r whole square. And if this height is very small, then you take this approximated result. G at a small height is g into 1 minus 2h by r. Okay, you don't take this formula always. Don't take this formula always. This formula is taken only when the h is comparatively small. Okay, but this one is true always. G into r by r whole square. So at a greater height, just like this, h is twice of radius of the earth. In this type of situations, this is the formula we are using to find the acceleration due to gravity at that particular point. Fine. Then gravitational potential and gravitational potential energy. Yes, there's another important concept. Consider this huge body, maybe earth of mass m. Okay. Then what is the potential at a point is the amount of work done to bring unit mass from infinity to that point. That's the definition. Okay. So I'm taking this potential energy at a point is potential into mass. Potential into mass. Okay. And the equation of potential energy of two masses Consider this mass capital M and this mass small m, and the separation between their centers is small r, then the potential energy is minus gmm divided by r. Minus gmm divided by r. Means potential at this point is potential energy by mass. If this is divided by mass, then mass is cancelled, then what is the potential at this point is minus gm by r. Minus gm by r is the potential at this point. Remember, this potential and potential is negative. We are assuming that the potential and potential energy at infinity is 0. At infinite separation there is 0 and there is maximum potential. Okay. So when r is less than this infinity's potential is greater. So as we move away from the surface of the earth, the potential and potential energy increasing. And where is the maximum value? At infinity. And it is assumed as 0. When the body is at infinite separation from the surface of the earth, there is no interaction between the earth and the body. Then we consider the potential energy of that body as 0. We are taking that. Now we are on the surface of the earth and there is interaction between us and earth. So we are having potential energy. As we move up, our potential energy increasing. And once we escaped from the gravitational pull of the earth, then our potential energy is taken as 0. As per that assumption, the equation of potential energy is minus gmm by r. Okay. So what is the potential energy on the surface? So usually in our earlier calculations, we are taking potential energy on the surface 0 and at a height h is mgh. Okay. We are assuming that. Potential energy on the surface is 0 and at a height h is mgh. Actually the situation is the potential energy difference of this point and this point is mgh. Potential energy difference is mgh. And if we are taking here 0, then here it is 0 plus mgh. Understood? If here we are assuming x, then what is here is x plus mgh. Okay. Okay. Now in this particular equation, we are assuming the potential 0 at infinity. Potential 0 at infinity, so here it is not 0 here on the surface. On the surface it is not 0. Okay. And on the surface, what about this small r is capital R, the radius? On the surface, what this small r is capital R. So what is the potential energy on the surface? Potential energy of a body on the surface of the earth is minus gmm divided by capital R. Potential energy on the surface minus gmm divided by capital R. And at infinity it is 0. Okay. So what is the potential energy difference of the surface and at infinity is gmm by r. Gmm by r. Okay. I hope you understood that concept. Potential energy, gravitational potential energy. And the situation of escape velocity, a problem of escape velocity is there. What about the escape velocity? We are projecting an object from the surface of the earth with a velocity v such that it never returns. Okay. It never returns means reached infinity. Okay. Throughout its motion, the only force acting on the body is gravitational force, and it is an example of conservative force. Okay. It's an example of conservative force means what is the work done by conservative force, or what is the, in the case of conservative force, we have explained that the conservation of mechanical energy is applied. Okay. Here there is kinetic energy, and as moving up, kinetic energy decreasing and potential energy is increasing. Okay. And the decrease in kinetic energy is the increase in potential energy, or delta k plus delta u is 0. Delta k plus delta u is 0. Applying the concept, we are getting that escape velocity is equal to root of 2 gm by r. Escape velocity is equal to root of 2 gm by r. Root of 2 gm by r. And we have the value of g on the surface is gm by r square. So what this gm value is always gr square. We can replace the gm value as gr square, then this will be root of 2 gr. This one will be root of 2 gr. And the value of g on the case of earth is 9.8 and radius of earth is also calculated. So this value in the case of earth is 11.2 kilometer per second. 11.2 kilometer per second. And the equation of escape velocity root of 2 gm by r. It is proportional to root m and 1 by root r. Okay. Now coming to this question. The escape velocity of a body on the surface of the earth is 11.2 kilometer per second. If the earth's mass increases to twice, the mass is increased to twice, so there is a 2 is here in the root. And the radius of earth becomes half. The radius becomes half means r by 2, and by 2 is moving to numerator. already 1, 2, and by 2, then 2 into 2, 4, root 4 is 2, then escape velocity is doubled. I hope you understood. Okay, here is 2, then r by 2, that 2 to the numerator, 2 into 2, 4, root of 4 is 2, and the escape velocity is doubled. And it was, earlier it was 11.2, and it's doubled means 22.4, 22.4 kilometer per second. It's option C. 22.4 kilometer per second it says, it is option C. Okay. Now what about Kepler's laws of planetary motion? As per Johannes Kepler, the planets are revolving around the sun through elliptical orbit, such that sun is at one of the focus. The sun is at this focus and the planet is revolving around this sun through this elliptical orbit. Okay. The gravitational force between the sun and the planet is central force. It is acting toward the center. Therefore, the torque acting on the planet based on the sun is 0. Therefore, the angular momentum of the planet based on the sun remains constant. Angular momentum of the planet remains constant based on the sun. Okay. That's why we are having the second law of Kepler, that the law of area. The planet traces equal area in equal interval of time. Okay. From P to P dash it is taking a time. If the time is same here from this point to this point, from A to B, then this area and this area will be same. That is, the aerial velocity is a constant, dA by dt is equal to constant. This is called Kepler's second law, that is the law of area, the aerial velocity. And this is derived by applying the concept of the conservation of angular momentum. Since angular momentum is conserved only, we are getting dA by dt is equal to constant. Okay. Now when the planet is away from the sun, it is moving with a less speed. And when the planet is nearer to the sun, its speed is increasing. Speed is increasing. All these concepts may be asked directly, true or false statement questions or etc. Okay. And another important law is the third law, that the square of time period of the planet is proportional to cube of the semi-major axis. Cube of the semi-major axis. This is the semi-major axis A. Square of the time period of planet is proportional to cube of the semi-major axis. Okay. Yes. T square is proportional to a cube. This is the third law. Was the first law is about this elliptical orbit. Second law is the law of area, aerial velocity is constant. Third law is the square of time period is proportional to cube of the semi-major axis. Yes. And that aerial velocity is, yes, L by 2m. That is the L by 2m is the aerial velocity. That's correct. L is the angular momentum and 2m is the twice of the mass. And since L is constant, the aerial velocity remains constant. Very good. Yes. Okay. Now, the application of this Kepler's third law is very often used in the case of satellites, or maybe comparison of the time period of two planets. That planet is having time period t, his radius is r, and this planet is having radius 2r, and what's its time period, etc. Comparison will be there, easily done. Okay. Kepler's second law regarding constancy of aerial velocity of planet is a consequence of the law of conservation of angular momentum. The law of conservation of angular momentum. This type of direct questions are also there. Don't think that all questions are highly numerical. Okay. And this type of very direct questions are also there. Okay. So be confident. Okay. Go through with these concepts, and this is very easily done. We can crack this NEET examination physics this time. Okay. Now, motion of a satellite. What about the motion of a satellite? See, this is Earth, and through a particular orbit a satellite is moving. Okay. This is actually an elliptical orbit, but it's considered a circular one, for example. And the centripetal force is provided by the gravitational attractive force. Is the centripetal force is provided. Okay. So we are cancelling this and we are getting this orbital velocity is root of gm by r. Root of gm by r. This is the orbital velocity. Okay. The orbital velocity is root of gm by r. Yes. Root of gm by r is the orbital velocity. And what about the time period is distance by speed. distance by speed. Time period of the satellite is 2 pi r divided by speed is root of gm by r. Gm by r. Okay. This time period is 2 pi r into root of r by gm. Okay. Then what about t square is equal to 4 pi square into r square into r. That is r cube by gm. Okay. That is t square proportional to r cube. T square proportional to r cube. T square proportional to r cube. This is our third law. Kepler's third law. T square proportional to r cube. Okay. Yes. Yes. Okay. Square of the time period is proportional to radius cube. Okay. Orbital velocity. Orbital velocity is root of gm by r. Root of gm by r. Okay. Now what about the energy of the satellite? That is this one. Energy of the satellite. See, this is the earth and the satellite is orbiting through a radius r. This is the satellite of mass m. Okay. What is this kinetic energy of the satellite is half into mv square. Half into m into what is the orbital speed square is gm by r. So what about this is gmm by 2r. Listen. Gmm by 2r is the kinetic energy of the satellite. Kinetic energy of the satellite is gmm by 2r. And potential energy of the satellite is minus gmm by r. Potential energy of the satellite is minus gmm by r. Potential energy of the satellite. Okay, you twice this kinetic energy and put a negative sign. Minus twice of kinetic energy is the relation between potential energy and kinetic energy. You twice it, 2 by 2 cancelled and put a negative sign. We are getting this potential energy of the satellite. And what about the total energy of the satellite is k plus u. The total energy of the satellite is k plus u. K plus u. K plus minus 2k. K plus minus 2k is minus k. Minus k is minus of this one. Minus gmm by 2r. Minus gmm by 2r. This is the total energy of the satellite is minus k. Total energy of the satellite is minus k. Total energy is minus k. And this minus k is total energy. So potential energy is twice of total energy. All these formulas are involved. Okay. Now listen me. There are questions. The satellite is taken from one orbit to another orbit. Satellite is taken from one orbit to another orbit. Then mechanical energy will be changed. What is the change in mechanical energy? That's the work done. Remember the work done by external agent to change the orbit of the satellite. To change the orbit of the satellite is change of mechanical energy. Change of mechanical energy. That is the change of total energy. Listen. Change of total energy. To change the orbit of the satellite from one orbit to another, the total work done by the external agent is the change of total energy. What is the total energy formula is minus gmm by 2r. Okay. From r radius to twice of r radius, what is the total work to be done is change of total energy. Change of total energy is final energy minus initial energy. Final energy minus gmm divided by twice of rf minus gmm divided by twice of ri. Okay. Then gmm divided by 2 is taken outside. 1 by ri minus 1 by rf is outside. This is the work to be done by the external agent. Maybe some rocket or something. Maybe some rocket or something. How much work to be done to change the orbit of the satellite. 1 by initial, 1 by final. 1 by initial minus 1 by final. Remember this. Okay. This situation is different in the case of, see, this is the satellite launching. And there may be question of projectile motion. Projectile motion. Okay. Projectile motion. Okay. That is a different situation. Listen that. Now, what about the next one is mechanical properties of solids. So those gravitation is very direct application of concepts. Go through with the questions, ask the doubts. We are having 4 more days. Okay. No moments to be wasted hereafter. Every moment is counted. Okay. Take only the rest time for the proper working of your brain. The rest time is only there deducted from 24 hours of a day, and the other time completely utilized for your subject preparation, question preparation, and do all these with maximum confidence without any disturbance. Okay, you guys have done all these things the last few years, and you are gathered so much concepts. Okay, practiced many questions, and that much confidence should be there with you, and that seriousness also. Okay, a calm, quiet, serious mind, preparing the questions, focusing, and this is the climax of your entire higher secondary career. Remember that. Okay, yes. Moving to these mechanical properties of solids. It's a very simple question, and all the questions are regarding the elasticity. Mechanical properties of solids, and here we are studying the elasticity. Okay, and we start with the stress and strain, then stress strain curve, then Hooke's law of elasticity connecting the stress and strain, then that ratio of stress to strain is called modulus of elasticity. Different types of modulus: Young's modulus, bulk modulus, rigidity modulus. Okay, moving to the topics. Okay, listen. First one is the stress and strain. When we apply a force on a body, then the restoring force per unit area. When we apply a force on the body to deform it, to change its shape, we are applying a force on the body. So the body is developing a resistive force, a deforming force. The deforming force per unit area is called the stress. Generally, the applied force and deforming force are taken as equal. It is taken as equal. Yes, yes. Then this stress is equal to F by A. Stress is F by A, force per unit area, its SI unit is Pascal. Okay. And what about this strain? Strain is the change in length divided by original length, or change in volume divided by original volume. This is the strain produced in unitless quantity strain. Okay. This is the stress strain. Its SI unit is Pascal. This is unitless. Okay. Now stress strain curve. Okay. Consider an elastic body. We are applying stress so that strain is produced. We are taking this stress on one axis and strain on another axis. It is found that the stress and strain are directly proportional up to a particular point, and up to this point Hooke's law is obeyed. Hooke's law is obeyed, and the proportionality is direct, linear relation. And after that there is a slopey, there is a curvy manner. Then from A to B, again the body is elastic. But this Hooke's law is violated from A to B because the proportionality is not linear. That's why Hooke's law we will discuss in the next slide. Okay, stress directly proportional to strain, and stress by strain is a constant. That is the slope of this particular graph. But here the slope is changing, so Hooke's law is violated, even though the body is elastic from O to B, but the body is obeying Hooke's law from O to A. After B, then there is a huge change in the strain, and this point is D, and this BD is called a plastic region. Then OB is called elastic region, and after this limit is reached, and there is a huge strain formed, and the body breaks, and this point is E, and that is called a fracture point. You understood? So OB is the elastic region, BD is the plastic region, and E is the fracture point. Okay. If D and E are very close, the material is brittle. It is breaking fast. If D and E are very close, brittle. And if D and E are very long, it is ductile. You have to note all these if you don't know. Otherwise, just listen and refresh your memory of your by hearting your concepts and leave it. Okay. If you don't know, just write all these things. O to A, Hooke's law obeyed. O to B, elastic region. Then B to D, plastic region. E is the fracture point. If these are close, then brittle. The material is brittle. And if it is far away, then it is ductile. Okay. This is NCERT figure, and question may come from that. And now, what about this Hooke's law of elasticity? Hooke's law is simply the stress directly proportional to strain. Okay, within the elastic limit. If this is obeyed in a particular region or in a particular stress strain region, that region is the elastic region of the body, and the proportionality constant K is called modulus of elasticity. Modulus of elasticity, that is K is equal to stress by strain. The modulus of elasticity, we know that is stress divided by strain. It is having the unit of stress. Unit of strain is unitless quantity, dimensionless quantity. A unitless quantity is definitely dimensionless. True or false? Yes, it is true. A dimensionless quantity is unitless. It is true or false? It is not true. Okay, those quantities are supplementary quantities which are having units but no dimension. Okay, and we are having this Young's modulus of elasticity. Young's modulus of elasticity regarding the length change. Suppose this is a wire, we are applying a force on it and the length is elongating, okay, delta L. Original length is L, the elongation is L. Then we are having the Young's modulus of elasticity is FL divided by A delta L. FL divided by A delta L. FL divided by A delta L. Young's modulus FL divided by A delta L. F is the force applied, L is the original length, A is the cross-sectional area, delta L is the change in length. Okay, change in length. Young's modulus of elasticity. For a particular material, Young's modulus is a constant. Okay, for one wire is of copper, the another wire is also of copper, means these two wires are of same material, then their Young's modulus will be same. Okay, Young's modulus of elasticity, and we are having problems based on this. Steel and copper, wires of same length are stretched by the same weight. Okay, same length, then same weight, one after the other. Young's modulus of steel is given and that of copper is given. The ratio of increase in length is delta L actually. We have Young's modulus formula is FL divided by A delta L. Then what about the change in length, increase in length? Delta L is equal to FL divided by AY. Okay, and what's the ratio of delta L of, which one is asked? First one mentioned steel. The ratio of increase in length of steel to copper, increase in length of steel to copper is equal to, applied same force, same weight is applied, so force is same. Okay, and same length, L is same. Okay, and no mentioning about the radius. I think that is missed in the question because this area also should be mentioned. Otherwise, radius is double, radius of steel is double of that of copper, etc. Something should be mentioned there. Nothing mentioned here, so I am taking the steel and copper wires of same length and radius. Same length and radius. You add this there. You add this there. Okay, that is missed there in the question. Then this area is also same. Pi r square is also same. Okay, then this only depends on Young's modulus. Different materials, one is steel, the other is copper. Then different Young's modulus. Okay, it is inversely proportional to Young's modulus. Okay, then delta L of steel divided by delta L of copper means Young's modulus of copper divided by Young's modulus of steel. Very direct ratio. And what about the Young's modulus of copper? It is 1.2. 1.2 into 10 raised to 11 divided by 2 into 10 raised to 11. Okay, then 1.2 by 2 is 12 by 20. Okay, 12 divided by 20, that is equal to 6 by 10, that is equal to 3 by 5. Okay, 3 by 5, it is this. If this is the answer, then they are having same radius also. Okay, otherwise radius ratio or relation will be mentioned in the question. Okay, don't worry. These are very direct questions, and this type of questions definitely will be there. You can easily solve. Okay, and bulk modulus. This is the case of volume change. We are applying pressure on the body. Consider this particular material, a three-dimensional material. We are applying a pressure so that a volume strain is produced on it. A volume strain is produced on it, and this ratio is called bulk modulus. But always this delta P and delta V will be opposite. If you are increasing the pressure means delta P is positive, then the volume is decreased. So here to get this bulk modulus positive, we are applying negative sign here. Bulk modulus is the applied pressure divided by volume strain with a negative sign, because delta P and delta V are always opposite. Okay, if this negative sign is not there, then this bulk modulus will be negative. In order to make it positive, we are applying this negative side. Okay, this is the bulk modulus of elasticity. Bulk modulus can be applied, can be defined on solids, liquids and gases. But Young's modulus is defined only in the case of solids. Okay, yes. And what about this rigidity modulus? The rigidity modulus is about the shape change. Okay, suppose there is a stick and we are applying the force at the upper edge and the lower edge is fixed here, then here is a shape change. And if this applied force is withdrawn, it is returning back. That's a property called elasticity. And what's the modulus of elasticity here in this particular context is called rigidity modulus. Okay, rigidity modulus. This is the situation. Suppose this was the body. We are applying a tangential force F on this particular area. So that the stress is F by A. This area is this area. Okay. And this is just sheared. The body is just sheared means its shape is like this. Okay. Then there is an angle theta here. Okay. What about tan theta is equal to delta x divided by L. Okay. That delta x by L is the corresponding strain there, and rigidity modulus N is equal to F by A divided by tan theta, or this rigidity modulus N is equal to F by A divided by tan theta. If theta is very very small, then tan theta is approximately theta, and we can say that F divided by A theta. F divided by A theta, this is the rigidity modulus, nothing else. Okay, this value divided by this value, there is a strain there. Okay, shearing strain, and this is the applied force tangential, and this force is applied into this particular cross sectional area. So F by A is the corresponding stress there. There's a case of rigidity or shearing, it is. Okay, that's about solids, and you practice more questions there. We are moving to the mechanical properties of fluids. Okay, so already 8 to 10. So what about this mechanical properties of fluids? The important topics are fluid pressure, then Pascal's law and application, very important. Then fluid dynamics. In fluid dynamics we discussed the equation of continuity, and the Bernoulli's principle is a very well known formula in fluid dynamics, Bernoulli's principle. Then some different topics of viscosity and Stokes law. Here the terminal velocity is there. Then surface tension is there, surface tension property, angle of contact and capillarity. These are the topics. No Reynolds number to be studied there. Okay. Then also there, then excess pressure is there, terminal velocity, etc. there. We can discuss all these things. Come on. Fluid pressure, consider a fluid of density rho. Here at this point, what is the pressure is? The pressure at this point may be atmospheric pressure PA plus pressure due to this much liquid content. Let this depth is H. Then what is the pressure at this point A is equal to the pressure at the top PA plus H rho G. Okay, this is the fluid pressure, and at a particular horizontal level the pressure will be same. At the same horizontal level pressure will be same, and this is Pascal's law. Okay, that's about the Pascal's law. Okay, the pressure difference of these 2 points is equal to H rho G, where H is this difference. This height is H. Pressure difference of these 2 points. So what the pressure here is, the pressure here plus H rho G. Okay, that's about a fluid pressure, and Pascal's law is at the same horizontal level pressure will be same. For example, this is a U-shaped tube is here. We are having 2 liquids there. One liquid is up to this much, and another liquid is up to this much. Okay, this is a liquid, this is a liquid, this one a particular liquid, and this is another liquid, this is another liquid. Okay, and here atmosphere is exerting pressure, here also atmosphere exerting pressure. Okay, then what about the condition is here? When you look into this figure, this green liquid, the pressure here, the pressure at this point and at this point will be same, because they are at the same horizontal level. Pressure at this point and at this point will be same. Pressure at A and at B will be same. Pressure at A and pressure at B will be same. That is Pascal's law. Okay. And pressure at A is pressure at this point, that is atmospheric pressure PA plus, let this be H1. H1 rho 1 G. H1 rho 1 G. Let the density of this liquid is rho 1. Okay, and what the pressure here, let this be H2, H2. Then what the pressure at the top is PA plus H2 rho 2G, H2 rho 2G, PA cancel, then G cancel. Okay, then if you get H1 and H2, you can easily compare this rho 1 and rho 2. Okay, maybe this one is 10 centimeter, this one is 8 centimeter. Then what the ratio of their densities can be easily calculated. Pascal's law. And also another application of Pascal's law is this hydraulic lift. That hydraulic lift is the another application of Pascal's law. Okay, here is a small piston, here is a large piston, and on the large piston we are lifting this vehicle. Okay, here this small piston we are applying this effort F1, so that a large force F2 is produced there. The area of cross section here is A1, the area of cross section here is A2, and since these two are at the same horizontal level, pressure here is F1 by A1 is equal to pressure here is F2 by A2. Okay, pressure will be same. Okay, yes, pressure will be same. And then what about this F2? What about this F1? The effort is, F2 is the load, F2 is the weight of this vehicle. Okay, and these areas, if these two areas A1 and A2 are given, and if load is given to you, what is the effort required? Since this A1 is less and A2 is much greater, then we require only just a small effort to lift this huge force. What about this? F1 is equal to F2 into A1 by A2. Listen to this. Since this A2 is much greater than A1, then this F2 is greater, but this product is very less. That's why this F1 is very less. In order to lift the huge load, we just apply very small effort. Okay, this is the application of hydraulic lift. Okay, that is application of Pascal's law. Okay. Yes. Yes. Nihas, stay with your confidence. Okay, you can crack it. Yes. Then Pascal's law, we already mentioned that, and fluid dynamics. In the case of fluid dynamics, we are discussing about this flow of fluid. Dynamics means motion. Consider this is a pipe of non-uniform cross-sectional area. Here this cross-sectional area is less, here the cross-sectional area is greater. Okay, and if the flow is streamline flow, consider a streamline flow of a particular liquid through this. Okay, then the fluid passing through this cross-sectional area will be equal in amount that the fluid passing through this cross-sectional area. Okay, that is the flow rate will be constant if this flow is streamline. If the flow is streamline, we are only studying about streamline flow in which the laws can be applied. If the flow is streamline, then we can have A1V1 is the volume per second passing through this one. Volume per second, A1V1. And that is equal to A2V2. This is the volume passing through the second area. The volume passing in any cross-sectional area will be same. That is AV is a constant. And this is called the equation of continuity, which means when area is less, their speed is greater. And when area is greater, their speed is lesser. Okay, fine. That is about the equation of continuity. What is called equation of continuity. And what about this Bernoulli's principle? What about this Bernoulli's principle is, see, in this particular fluid flow, then considering two different points of fluid flow at different heights, H1 and H2, let this pressure here, the fluid pressure is P1, velocity is V1, the pressure here, fluid pressure P2 and velocity V2, then P1 plus half rho V1 square plus H1 rho G is equal to P2 plus half rho V2 square plus H2 rho G. This is Bernoulli's principle. Okay, suppose these 2 points are at the same height. If 2 points are at the same height, then H1 rho G and H2 rho G can be cancelled. In that particular case, we write P plus half rho V square is a constant. Listen, this is very important. Okay, just like in the case of wing of an aeroplane, the bottom of the wing and the top of wing are not having much height difference from the surface of the earth. Not having much height difference. Okay, then at the bottom of the wing and at the top of the wing, we can write P plus half rho V square is a constant. Is a constant. Means wherever the speed of flow is greater, there the pressure will be less. speed of flow greater means this quantity greater means pressure will be less. Okay, this condition is called Bernoulli's principle and its applications are there. Okay, now what about this viscosity and Stokes law? Come on, this viscosity and Stokes law there. Consider a viscous fluid. Consider a viscous fluid through which a spherical ball is moving. A spherical ball is moving through a viscous fluid. Then the fluid will exert a viscous force, a resistive force there, that is equal to 6 pi RV, 6 pi eta into RV, 6 pi eta into R into V. This is called Stokes law, where eta is called coefficient of viscosity. Eta is called what? Coefficient of viscosity. Eta is called coefficient of viscosity. Okay. Yes, the time is already 8:15, so we can have a quick revision of these topics. Okay. Eta is called coefficient of viscosity. And suppose there are two fluid layers are there of area A. Consider two fluid layers of area A. Then one layer is exerting a viscous force over the other layer. Then that viscous force Fv is area into dV by dx, where the separation of this layer is dx and the velocity difference of this layer is moving with a velocity v and this layer is moving with a velocity v plus dv. These two layers are moving at a different velocity due to this resistance. And what the velocity difference is dv and what the separation is dx. So what is this dv by dx is called, here is eta, one constant is there, that is eta, coefficient of viscosity. Yes, eta is there. Torricelli's law we can discuss. Then eta into A into dV by dx is there. dV by dx is velocity gradient. A is the area, eta is the coefficient of viscosity. Okay. And there Venkat is asking about the Torricelli's law. See, the Torricelli's law is actually, if there is an open tank and there is a hole created, a hole is created, okay, then there will be velocity of efflux through the hole, the liquid will be ejecting and the velocity of ejecting will be equal to root of 2gh. This equation is Torricelli's law, where h is the depth of the hole from the surface. H is the depth of the hole from the surface, okay, and the velocity of ejection is root of 2gh, and this is called what? Torricelli's law. This velocity of ejection is root of 2gh is called Torricelli's law. Okay. Now here we are discussing the viscosity and Stokes law is already mentioned. Remember, this viscous force is proportional to the radius and also the speed. Speed is increasing, viscous force is increasing, radius is increasing, viscous force is increasing, and here is a coefficient of viscosity is here. Okay, coefficient of viscosity eta is here. Okay. Now moving to the next one is surface tension. What about the surface tension is, see, when there is a container in which a liquid is taken, listen, the surface molecule and the molecule inside, these two molecules are having different energies. Okay, it is found that the energy of the surface molecules are greater. Okay, energy of surface molecules greater, so the surface will try to reduce the number of molecules on the surface to possess minimum energy and maximum stability. Okay, that is surface tries to reduce the surface area, tries to reduce the area. Surface tries to reduce the area, okay, which leads to surface tension. Surface tries to reduce the area and which leads to surface tension. Okay, yes. Then what is the additional energy, surface energy possessed by these molecules? Surface energy divided by area is called surface tension. Surface tension I am taking as S. Surface energy, the additional surface energy divided by area is called surface tension. Okay. Then how much work is needed? What is the surface energy equation is surface tension into area. So how much energy is required to increase the area? The energy or the work done to increase the area is surface tension into additional area, change in area. This is the work done to increase the area. Okay, work done to increase the area. Suppose this one is a small drop, it is splitted into n identical drops. Okay, in this particular case, this area is equal to 4 pi r square. Okay, this area is equal to 4 pi r square. This area is equal to 4 pi r square. And what this is, the final area A dash is equal to n into 4 pi r square. N into 4 pi r square. Suppose this n identical drops are formed. Okay, this A dash is greater than A. You can use this capital R is n raised to 1 by 3 into small r. This is the relation between capital R and small r. Okay, by equating the volume. Here the volume and here total volume are equal. Then we are getting this. So here in this process, the total area is increased. Total area is increased. For this particular process, we need to do work. How much work we need to do is the surface tension into additional area or increase in area. What is the increase in area? Is A dash minus A. A dash minus A into surface tension. This much amount of work is done to split this. Okay, that's about surface tension. And now what about this angle of contact? Come on. Suppose a liquid drop is placed over a particular surface, a glass plate or something, a liquid drop is placed. Okay. Now this is spreaded over the surface. Spreaded. And when you consider tangent here, you can get an angle between this tangent and the solid inside the liquid. This theta is called angle of contact. This is called angle of contact. Suppose in another situation, a liquid drop is just having very least contact. Very least contact means this is the tangent and this is the solid inside and this angle is theta. Now if there is only very least contact, like in the case of mercury, angle of contact is much greater. And in the case of water like this, angle of contact is less. So angle of contact less means it is more spreading. More spreading means more wetting character. More wetting character. And if angle of contact is obtuse, it is very least spreading there and very least wetting character. Okay, very least wetting character. And here in this case of this surface tension, there is a relation. As temperature increases, listen me. As temperature increases, you can understand surface tension decreases. As temperature increases, you can understand what? Surface tension decreases. Okay. Now here also, as temperature increases, you can understand this angle of contact decreases. Surface tension increases, angle of contact decreases, more spreading and more wetting character as temperature increases. Okay. Now capillarity. Consider a liquid taken in a container. Okay. And there is a capillary tube is inserted. Okay. The liquid is rising through this capillary tube. Liquid is rising through this capillary tube to a particular height. This is called a capillary rise. And the formula for capillary rise, H is equal to 2s cos theta divided by r rho g. 2s cos theta divided by r rho g. Where theta is the angle of contact, here you can see angle of contact theta. Here is the angle of contact theta. And S is the surface tension. S is the surface tension. R is the radius of the capillary tube. R is the radius of the capillary tube. Rho is the density and G is the acceleration due to gravity. Remember its relationship between H, S, R. Okay. H, S, R. Relationship is to be carefully listened. Okay. Now moving to the next one. Okay, we are having very limited time, so I am just quickly revising the topics. In thermal properties of matter, temperature scales, Celsius, Fahrenheit, Kelvin. Thermal expansion, linear area, volume expansion, solid expansion, liquid expansion, gas expansion. Heat capacity, specific heat capacity. Okay, calorimetry. Calorimetry is there. Conduction of heat. Conduction and convection of heat. Radiation is not there. Radiation, Newton's law of cooling, then Stefan's law, Wein's law. Okay, no questions coming from those topics. So if you already didn't study those topics, leave them there. Okay, and you focus on all these topics, temperature scales. Okay, what about this temperature scale? Suppose C is the Celsius scale, C is the Celsius scale, F is the Fahrenheit scale, K is the Kelvin scale, and T is some another scale. Then what the relation is? C by 100 is equal to F minus 32 divided by 180 is equal to K minus 273 divided by 100 is equal to T minus T ice divided by T steam minus T ice. Okay, this is the relation connecting different temperature scale. Okay, for example, in a particular scale, T ice is 2 degree and T steam is 102 degree. T steam is 102 degree. Okay, then 150 degree is equal to dash degree Celsius. 150 degrees dash degree Celsius. So I am connecting C by 100 with this equation. C by 100 T minus T ice divided by T steam minus T ice. Okay, then what is this? T value is 150, T ice is 2, T steam is 102. So we get this 150 minus 2 divided by 102 minus 2. Okay, this one you solve. Okay, then what? 102 minus 2 is 100, 100 cut. Then what is C is equal to 150 minus 2, 148 degrees. 148 degrees is the answer of this question. 148 degrees C. Okay, in this way we can connect the different temperature scales. Okay, that is very easy. Now what about the thermal expansion? There is linear expansion is there. What is the linear expansion coefficient? Is delta L by L delta T. Delta L by L delta T. There is the area expansion coefficient is there, delta A by A delta T. Delta A by A delta T. There is a volume expansion coefficient is there, delta V by V delta T. It is there. And in the case of a particular solid, what is the relation connecting this? Alpha is to beta is to gamma. Alpha is to beta is to gamma is 1 is to 2 is to 3. 1 is to 2 is to 3. Okay, this is the relation connecting different expansion coefficient. Okay, simply we are just revising. And what about the heat capacity? You know, the specific heat capacity is the amount of heat required to increase the temperature of m mass of a body by delta T. Amount of heat delta Q by m delta T. This is specific heat capacity. So how much heat is required to increase the temperature is mc delta T. Delta Q is the mc delta T heat capacity. This is specific heat capacity. Specific heat capacity. This is specific heat capacity. And there is another latent heat. What about latent heat? Is the amount of heat required to convert m kilogram mass. Then delta Q by m is the latent heat, or delta Q is the amount of heat for state change is m into L. This is for state change. For state change. M into L is for state change, and this is for temperature change. For temperature change. Okay, this is for temperature change. Okay, what about the next? Calorimetry. Suppose we are adding two different quantities. Suppose this material is mixed with this material. Okay, then one is, suppose this is at T1 temperature, this is at T2 temperature. If T1 is greater than T2, then heat is flowing from this body to this body. Okay, then amount of heat lost by one body, that is equal to the amount of heat gained by the other body. And this is called the principle of calorimetry. Okay, and the temperature of this body may decrease and temperature of this body may increase. Otherwise there may be state change also, possibility is there. Okay, then what about the conduction of heat? Yes, consider a conductor. At this end T1 and at this end T2. If T1 is greater than T2, then heat will flow from end A to end B. It will flow from end A to end B. Then what is the heat current? H is equal to thermal conductivity K, then area of cross section A, then delta T by L. This is the heat current formula, where K is called what? Thermal conductivity. K is called thermal conductivity. Okay. Then what about the convection of heat? Suppose we are taking a liquid and we are heating the liquid. Okay, the heat will be conducted from base to this one, and the molecule, heated molecule, will be moving from this point to this point, and this, the heating of the entire liquid due to actual motion of the particle, is called convection of heat. Yes, no more problems from convection, but there will be possibility of problems there from conduction. Okay, there is heat to current, combination of conductors, thermal resistors, etc. All topics should be carefully revised, okay, because radiation already deleted, then more possibility from conduction is there. Remember that. Okay. Thermodynamics. In thermodynamics, what topics we study? Zeroth law of thermodynamics, just about thermal equilibrium. Temperature will be constant if two systems are in thermal equilibrium. And first law of thermodynamics is regarding the heat, work and internal energy. And thermodynamic process, isothermal, adiabatic, these are very, very important. And isobaric, isochoric also, you just try to understand. And second law of thermodynamics is mentioned there, but no heat engine is there. Heat engine is deleted. But just understand second law of thermodynamics, there is no heat engine with 100% efficiency and no refrigerator with infinite performance. That is second law of thermodynamics. No other complicated problems of heat engine and refrigerators, not there. You just focus on these topics. Mainly the relation between heat work and internal energy. Okay. What is the zeroth law of thermodynamics? Means when two systems are in thermal equilibrium, their temperature will be same. Okay. When A is in equilibrium with B and A is in equilibrium with C, then B and C will be in equilibrium with each other. That is the zeroth law of thermodynamics. Okay. And first law of thermodynamics is simply this: heat given to a system is utilized to increase its internal energy delta U and to do work. Okay. Remember this delta U formula will give you F by 2 NR delta T. Okay. Then this F is the degree of freedom for monoatomic gas. For monoatomic gas it is 3. For monoatomic gas F is 3. For diatomic gas F is 5. For diatomic gas F value is 5. Okay. Then N is the number of mole, R is the gas constant, delta is the temperature change. This is the equation of delta U. And the amount of work done by a gas is integral PdV. Remember this basic formula. From initial volume V1 to final volume V2. Okay. This is the first law of thermodynamics. And different questions possible based on delta U. They may give you the monatomic gas. Then you take F as 3. Number of mole mentioned. R is mentioned. 300 to 500 mentioned means this change is 200. Then delta is there. Okay. Then work done formula is there. Work done formula we will discuss while discussing the thermodynamic processes. In the case of isothermal process, you understand delta T is 0, so delta U is 0. Then what about delta Q? And the work done will be same. And another formula of isothermal work done, you by heart this nRT into ln of final volume by initial volume. nRT into ln of final volume by initial volume is also the work done in the case of isothermal process. Okay. And adiabatic process, what this is, there is no heat exchange. There is no heat exchange means delta U is minus delta W. Okay. So this adiabatic work done is negative of the internal energy change. And what is this negative of internal change is F by 2 NR into minus delta T, minus delta T, minus delta T. And this is also obtained as NR divided by gamma minus 1 into initial temperature minus final temperature. Quickly revise these topics and you solve some problems. Okay. Then what about this isobaric processes? There is no pressure change. There is no pressure change. Then this work done during isobaric. Work done during isobaric is pressure into change in volume. Pressure into change in volume, it is also NR delta T. Work done during isobaric process is NR delta T. Okay. Then what about this isochoric process? Isochoric process, there is no change in volume and the work done during isochoric process by a gas is 0. If work done is 0 means whatever heat you supply will be completely utilized to increase the internal energy in the case of isochoric process. Okay. And what about the second law of thermodynamics? That there is no heat engine with 100% efficiency. Okay. Definitely there are questions from thermodynamic process, but as of now we are skipping all those problems and I am free there up to your next NEET examination. You can ask me the doubts, clear your doubts, and do with utmost confidence your examination. Come on, this kinetic theory of gas. The first one is the assumption, the postulates of kinetic theory that also you study in chemistry, and pressure of an ideal gas, then kinetic energy and temperature, then RMS speed, then molecular speed, RMS speed, average speed, and most probable speed. Assumptions, kinetic theory of gases. A particular container of gas contains a large number of tiny molecules. The molecules are in continuous random motion. During their motion they collide with each other and also with the wall of the container. Collisions are perfectly inelastic. Okay, there is no interaction between the gaseous molecules. Okay, thus the internal energy of the potential energy of the gas molecule is 0. Potential energy of the gas molecule is 0. Therefore, the internal energy is purely kinetic, and the internal energy formula is F by 2 nRT. F by 2 nRT is the internal energy formula, and delta is F by 2 nR delta T. We studied earlier. Okay, these are the assumptions, quickly revised. And what about the pressure of an ideal gas? Suppose we are taking an ideal gas in a particular container. The gas is exerting pressure P is equal to 1 by 3 into N into M into VRMS square. Remember, this N is not number of moles. This N is the number density, total number divided by total volume. This is not number of moles, it is number density. Okay. Then what about this kinetic energy and temperature? See, kinetic energy, in the case of gas, it may have kinetic energy in 3 ways. One is translational kinetic energy. Generally, I may write this kinetic energy is equal to, kinetic energy is F by 2 nRT. This is the means internal energy as well. This is the internal energy as well. Listen this, F by 2 nRT. This internal energy is purely kinetic energy in the case of ideal gas, because no potential energy. So this internal energy is purely kinetic energy. So this one, kinetic energy is F by 2 nRT. The case of translational kinetic energy is 3 by 2 nRT, because translational degree of freedom is 3. Okay, so this kinetic energy depending on number of mole. This is number of mole, okay, not number density. This is number of mole written here, and it's also proportional to absolute temperature. Okay, in a particular room or in a particular container, temperature of all gases will be same. So kinetic energy depending only on the number of moles and also on degree of freedom. So if it is question about translational kinetic energy of the gases taken in a container, it only depends on the number of moles. And kinetic energy per mole will be a constant, because temperature constant for all gases. Kinetic energy per mole, okay, will be the ratio kinetic energy per mole of hydrogen and oxygen taken in a container. The ratio is 1:1, remember. Okay, and what about the RMS speed? RMS speed of a particular gas is root of 3RT by M. Root of 3RT by M. This is the RMS speed. Remember, its proportionality with temperature and molar mass. Okay, root T and 1 by root M. Okay. Now what about this oscillation? A quick revision of oscillation is doing here. Periodic and oscillatory motion. All oscillatory motions are periodic, but all periodic motions are not oscillatory. Studied. Simple harmonic motion is a particular motion in which displacement is varying sinusoidally or cosine variation. Then displacement is the velocity of SHM, acceleration of SHM, force law of SHM, energy of SHM, kinetic energy, potential energy, total energy of SHM. Simple pendulum, oscillation. Then oscillation of a spring. Okay, these are the quantities of oscillation. Then periodic and oscillatory motion is there. Then what about this displacement formula? We are writing this x is equal to amplitude into sine of omega t plus phi. Okay, this is the amplitude, this is the angular frequency, phi is the initial phase angle. Clear? And what about the velocity is here? A omega cos omega t, or a omega cos of omega t plus phi. Okay, we are in detail, we discuss all these things. You know, Vmax is a omega, maximum speed is a omega. Okay, and what about the acceleration is minus omega square into displacement. Acceleration is minus omega square into displacement. Acceleration, okay, minus omega square into displacement. And force law is that F is equal to minus k into x. F is equal to, there should be a force acting on this particle that is proportional and opposite to displacement, then only the motion becomes simple harmonic. Okay, that is f plus kx is 0. F plus kx is 0. That is ma plus kx is 0. Ma plus kx is 0. That is a plus k by m into x is 0. This is 0. That is d square x by dt square plus k by m into x is 0. This is this one. K by m into x is 0. And this is the omega square. Omega square is k by m. Omega square is k by m. Omega is root of k by m. Omega is root of k by m. 2 pi by time period is omega, it is root of k by m. Remember, k is force constant, m is the mass of the oscillator. So what is the time period of the oscillator is 2 pi into root of m by k. Time period. All these formulas are there, very direct. What the relationship of time period with the mass and force constant, etc. is very clear here. Okay. What about the energy of SHM? The kinetic energy of SHM is half then m omega square. M omega square is k. Then a square minus x square. A square minus x square, where a is the amplitude. Potential energy of SHM is half k into x square. Potential energy of SHM is half k into x square. Total energy of SHM is sum of these two. Sum of these two is half into k into a square. Okay. This is the energy of SHM. Total energy always a constant independent of x. Yes. What about simple pendulum? One end of the string is connected to rigid support. The other end is connected to a bob, and it is oscillating with a small angle oscillation. Small angle oscillation is SHM, and the time period t is equal to 2 pi into root of L divided by G effective. G effective. G effective. Suppose this is in a lift accelerating upward, then this G effective is G plus A. If this is in a lift accelerating downward, then this G effective is G minus A. Suppose this is in free fall, then G effective is 0, then time period is infinity, etc. These are the questions of simple pendulum. And the oscillation of a spring also we discussed in the case of work energy power. Okay, if it is displaced and released, it is in oscillation. It is in oscillation. And what about the time period is 2 pi into root of m by k. The time period is 2 pi into root of m by k. Okay, and when the spring is cut, then when the spring is cut, what is the theory? When a spring is cut into pieces, when a spring is cut into pieces, what the theory is? Suppose it's having constant k and length L. It's having constant k1 and length L1. It's having constant k2 and length L2. Then our theory is KL and K1 L1, K2 L2 all are same. K into L, then K1 into L1 and K2 into L2 all are same. Okay, that is the spring constant and length relationship. Okay, now about this one, waves. Come on, this is our final topic. Types of mechanical wave. Mechanical wave, what are the different types of mechanical wave? There is longitudinal wave and transverse wave. Then displacement of a mechanical wave, displacement of, then speed of a mechanical wave, omega by k. Speed of transverse wave along a string is root of t by mu. Then speed of sound is root of b by rho. Root of bulk modulus by rho is there. Okay. Then standing wave along a stretched string, in a closed pipe, in an open pipe. Okay. Yes. Come on. First the topic is types of mechanical, longitudinal wave and transverse wave. The relation is, what is the longitudinal wave is the oscillation and propagation will be in the same direction. The oscillation of the particle and propagation in the same direction, that is longitudinal wave. And what about the transverse wave? The propagation of energy and the oscillation of particles are perpendicular to each other. This is the transverse wave. Okay. Now, displacement of a mechanical wave is x is a into sine of kx plus or minus omega t. Listen, this is the amplitude. K is the wave number 2 pi by lambda. K is the wave number 2 pi by lambda. Omega is the angular frequency 2 pi by t. Okay. If kx and omega t are of same sign, then the wave is propagating along negative x direction. Okay. If kx and omega t are of opposite sign, then a wave is propagating along the positive x direction. That is also very important. And the wave speed formula is there. Wave speed. Speed of transverse wave along string. Generally wave speed formula is here. The speed of the wave is omega by k. And it is also equal to nu lambda. It is nu lambda and also lambda by t. All these are possible. Speed of a wave. Speed of a wave. Okay. Now listen, speed of a transverse wave along a string. Suppose this is a string stretched between two rigid supports. So there is a tension acting here on the string. A tension is acting on the string. Then what the speed of the wave on this stretched string is root of t by mu. T by mu. Remember this mu is mass per unit length, m divided by L. Mass per unit length. Mass per unit length. Okay. And what about this speed of sound? Speed of sound is root of bulk modulus divided by density. Okay. Then there is Newton's formula. Newton's formula is, what about Newton's formula is root of, V is equal to root of, bulk modulus is equal to pressure. According to Newton, he thought that bulk modulus is equal to pressure. And what was the Laplace correction? Laplace correction, you know. What about the Laplace correction? Laplace thought that the propagation of sound through air is adiabatic, not isothermal. Then the bulk modulus is equal to gamma p by rho. Gamma p by rho. Okay. You know what's the next one is standing wave along a stretched string. Along a stretched string, when standing waves formed, then what is the fundamental frequency? You know, the fundamental frequency, fundamental nu naught, fundamental frequency V by 2L. V by 2L. And what is the first overtone is twice of V by 2L. And what is the second overtone is 3 times of V by 2L. 3 times of V by 2L. So both odd harmonics and even harmonics are possible in the case of transverse wave along a stretched string. This is the same situation in the case of this closed pipe also. In the case of closed pipe also, this fundamental frequency V by 2L, first overtone is 2V by 2L, second overtone is 3V by 2L. Okay. So stretched string and closed pipe, similar pattern of frequency we are obtaining. Okay. And in the case of a closed pipe, the fundamental frequency is V by 4L. V by 4L. This is the length of the closed pipe. Okay. V by 4L. And the first overtone is 3V by 4L. Listen this. And the second overtone is 5V by 4L. So only odd harmonics only possible in the case of closed pipe. Okay. And the case of open pipe we already mentioned. And what about the beats? Suppose there are two frequencies, one is nu1 and another is nu2, very slightly different. Then the beat frequency is equal to nu1 minus nu2. Beat frequency is nu1 minus nu2. For example, if one frequency is 300 Hz and the other frequency is 301 Hz, then what is the beat frequency is 1 Hz. Okay. So remember students, the time is already approaching 9 p.m. Okay. So it is time to wind up this live discussion right now. Okay. The last topics, we are just only having this quick revision of the topics. Lot of questions there. Already we discussed in the offline session so many questions. Okay. So you go through with the questions again and again and boost your confidence. Okay. And again I am telling you, I am there. Okay. Observing you, watching you, and all of your doubts, okay, welcomed, and we will answer all those doubts. And whatever topics we discuss from each chapter today, you focus only on those topics. No other topics you take in the coming 4 days. Okay, only this much topics are there and all other topics are deleted. But lot of questions are there definitely here in beat. Lot of questions will be there. You can prepare different questions there and boost your confidence, boost your concepts, and write the examination. Okay, crack it right now. You can do it. You can win it. Okay, thank you guys. Good night and good luck.